So folks, let's start with our basic programming in JavaScript. JavaScript is a very vast language, and to be very honest, not only JavaScript, but a lot of languages like C++, Java, JavaScript, Ruby, all of these languages are very vast. You cannot expect yourself to be a master in these languages in one day. Just think about it like English. You spent like what, 7, 8, or maybe 10 odd years in your school days to actually master English. And to be very frank, still we have a lot of things to learn in English, right? We also don't know everything in English, something that we spent what, like 10 odd years. Similarly, these programming languages also demand a lot of dedication, right? There are a lot of advanced corner concepts that are different in a lot of languages. But the best part about programming languages is, for getting started with them, if you want to just getting if you just want to get started with any programming language like C++, JavaScript, Java, anything. So for getting started, if you somehow understand one language, then for getting started on another language is going to be what, maximum 3 to 4 days task, because the concepts, the foundational concepts, right, that actually are taught in the start, or you have to understand in the start, are common in all of the languages. That is the best part, due to which we will be able to handle most of the things very easily, right? So my point being that if you are getting started with JavaScript, don't expect yourself to become a master in JavaScript in like one day or one week. Here we are going to first of all start with beginner JavaScript. Later, maybe in some other parts, we can even take advanced concepts of JavaScript. I'm teaching you JavaScript till an extent that we can at least get started with algorithmic problems, data structure problems, right? Puzzles and everything. So make sure that you keep your patience, right? You sit back tight, even if you already know some language, right? Because once we are done with the basic part and we do a bit of algorithmic stuff, the advanced part of JavaScript is going to be extremely interesting. So let's start. So now we are going to start with basics of JavaScript. Basics of JavaScript, right? Okay. Now JavaScript is technically a multi-paradigm programming language. In JavaScript, you can do functional programming also, procedural programming also, and now you can even do object-oriented programming also. I guess everybody basically knows that, and we are going to eventually talk about multi-paradigm again when we will come to the advanced stuff. But JavaScript is just like any other programming language. The basic foundational concepts are same. So let me take another example in front of you. So let's say, so I'm going to open a browser window in front of you. Okay. Now I believe everyone loves games, right? So I'm going to search for online tic-tac-toe. Okay. I'm going to search for some like online tic-tac-toe. Okay. So let's see. So this is the first website that I'm getting. Looks fine to me, right? There are a lot of ads although, but we can just close them up. Okay. Now on this website, you can see there is a bit of UI, right? There is player X, there is computer 0. So we will be playing with symbol X. Computer will be playing with symbol 0. If the match will be tie, we will get it here. So let's see. If let's say I put a X here, I click and I put a X here, then the computer puts a 0 here. Then let's say I put a X here, computer puts a 0 here, and I put a X here, and we win, right? And we win. And you can see, because we win one game, the counter is 1 here. The counter you can see is 1 here for player, that is us, and counter is 0 here for computer, that is the automated computer system. Now you might be thinking why I am telling you, right? You might be thinking why I am telling you. So see, if I click another anywhere on the screen, it starts another game. Let's try to win this game as well. Okay. So now You can see we won another game, and you can see now the counter is 2. Now the counter is 2. Okay, looks fine to me. If I refresh, if you are not able to see the counter, let me just zoom in a bit. So you can see the counter is not 2. If I refresh, you can see the moment I refresh, everything got refreshed, right? And the counter is 0 again, right? Let me zoom in a bit. And the counter is 0 again. You can see the counters are 0 again once I refreshed. So what is going on? What do I want to actually tell you guys? So let me tell you. So any piece of software that you are building needs to store some information, right? For example, the tic-tac-toe, that the game that we just saw, it has to also store kind of like some piece of information. That is, let's say, what is the score of the player, right? Or maybe in your tic-tac-toe grid, what positions computer has marked, what position I have marked, right? These things need to be stored somewhere, right? These thing needs to be stored somewhere. If let's say I refresh the game, if I refresh the whole piece of software, let's say refreshing on a web app is equivalent to saying you just close the application and run it again. So everything is refreshed. All the storage spaces are reset. Now the player's count was again 0 and computer count was also again 0. You have to restart. My point being, in any piece of application that we are going to develop, we need some space, some area to store our data, some area to store our data. Now, what actually happens is, whenever we run a software, let's say this is a piece of software, right? Some software, right? This software must have been written or coded in some programming language. So I'm going to say this is the code of some software. If I want to run the software, then what actually happens is we call this piece of code of the software as a program. This is a program that we are going to write. For example, let's say if I want to build my own tic-tac-toe, I have to write some JavaScript knowledge that we are going to eventually see when we are good with JavaScript. So we are going to write some piece of code, and once that is done correctly, we will be able to play tic-tac-toe on it. So the coding information that we are going to write in a file is going to be a program. What happens is, when you want to run this program, right, there are different ways to run it. Different languages are going to be run in different ways. When we are going to run it, this program, which we have stored in some file, right, this is going to be loaded inside our RAM. So let's say this is our RAM. What is RAM? RAM means random access memory. This is the primary storage area. Inside this RAM, let's say I have a 4 gigabyte RAM, for example. So what happens is, when you want to run this piece of software or run this program is loaded inside your RAM and it becomes a process, right? It becomes a process here. So you can say that program in a running state is called process. Simple terms, if I define process, in a running state is called process. So whenever we run this piece of software, it becomes a process. For example, let's say I open a Chrome browser or Mozilla browser, right? So somewhere in your computer system, you have downloaded the whole setup of Chrome, right? So all the piece of code of Chrome is there. When you double click on it and try to run it, then that program that is stored, which was not getting used until or unless you ask it to be uh, executed, when you double click on it, that program is loaded in the RAM for execution. And when it is loaded in the RAM and the execution starts, it becomes a process. So a program in a running state is called a process. So if you want to see all the process in your computer system, if you're using Windows, you can open Task Manager. I am assuming that you might have been already well versed with Task Manager. So on Task Manager, you will see a lot of tasks, or you can see a lot of process, right? So for example, if you will double click on VLC Media Player, you will see a new process that will pop on the Task Manager, right? In Mac, you can even have System Monitor. I guess it is, 1 second. I forgot the name. Let me just quickly check. Just second, let me show you on Mac. Activity monitor, sorry, it's not system monitor, it is activity monitor. Right, if you want to see on Mac, you can check activity monitor. You can see this is my activity monitor, right? If I go to memory, see I'm in the memory. So all of these processes are running. For example, I'm running Mozilla Firefox. So it is shown as a piece of software that is loaded as a process. See, all the process names are there. So Mozilla in itself takes 12 GB. It is taking 12 GB of my RAM, right? Quite a good chunk it is taking. Then let's say Zoom is also there. So it is taking 200 MB, right? Now let's say I close Zoom. Let's say here, I'm going to close Zoom. So let me put Zoom here. If you will see, Zoom is currently running. You can see this white dot. If I click on it and click on quit, right? So Zoom is now no more there, and you can see from my process list also Zoom is gone. So whenever you run a piece of software, it is loaded as a process. Now you might be thinking why I am telling you all of this. Now RAM is a primary storage area, or you can say it's a storage device. That means if a program is loaded as a process, it gets some memory allocated to it from the RAM. For example, my RAM was having 4 GB memory. So let's say the RAM allocates 512 MB to my process. I'm just giving a random example that when I run my program and it converts into process, some 512 MB of my RAM gets allocated to this process. Let's say I run another program and that gets converted to process, it will take some more memory and so on and so forth, right? So now what is the use case of this memory? Inside this memory, we can do some storage. As I just showed you that in the tic-tac-toe game, we need to store the player score. Maybe you want to take the name of the player also. So you might need to store the name of the player. So we need some storage area for all of this. And we can use this RAM as the storage area. And just think about it. Once we close the process, all of the data will be gone. When we will restart, we can restart from scratch. So whenever we are going to run a program, that program gets loaded in the memory as a process. This process gets some storage area from our RAM. That means inside our program, we can write logics so that we can store some piece of information very easily. And where that piece of information will be stored, that piece of information will be stored inside the RAM. So now we have to see that how can we store this piece of information. When we are dealing with a programming language, so inside programming language, there are some special words that we cannot use for our use case anyhow we want, right? So there are some special words which have got some special meaning to the programming language, right? We cannot modify it based on our wish. So these things are called as keywords. These things are called as keywords. So in a programming language, few words are reserved by the language for its own purpose. We cannot change their meaning. We cannot change their meaning or repurpose them for a different use case. For a different use case. For example, let's say in English, you have some punctuation marks. You know, right? These are reserved. If let's say there is a question, then it is definitely going to somehow give a feeling of a question asked, right? There are like vowels that are fixed, like A, E, I, O, U. These are vowels, right? So there is rule that only these 5 characters are vowel, right? So just like that, in programming languages also, there are some words that are reserved by the programming languages. Different programming languages can have different reserved words. These reserved words are not expected to be used by us for anything. They will be having their special meaning. They will be having their special use case. For that particular use case only you have to use the keyword. Otherwise, language is not going to allow you to do that. These kind of words are called as keywords, right? So, for example, in JavaScript, few keywords are let, for, const, if, else, return, etc. There are a lot of keywords. I'm just naming a few. So these keywords, you cannot just use it for your own purpose. You can only use them for their intended purpose that is defined inside the programming language. This is defined inside the programming language. We cannot, I would say, change that. So these are reserved for the programming language. That's why we call them as keywords. So whenever I will say keyword, so you should get a notion that this is a word which is reserved for the programming language use case. So we are going to learn about that use case and we are going to move forward. We cannot just change the use cases anyhow we want. That cannot, like that particular thing can not happen. Now we know that we have keywords, and now we also know that we need to store some piece of information based on the software that we are trying to build. So how can we store some values inside a program? How can we store some values inside a program, or specifically saying JavaScript program? So to store values, we can use variables. Now you might be thinking, what are variables, right? Right? So let's say that this is your RAM. Okay. Inside your RAM, you got 512 MB for your particular process, right? For a particular process, you got 512 MB. Now inside this 512 MB, what will happen is you want to store some piece of information. So technically, what you can do is you can create a bucket in the memory. You can create some bucket in the memory. Inside this bucket, you can store some value. For example, let's say 12. I'm going to store a value 12 inside this bucket. And this bucket will be also having a particular name. You can also name this bucket. You can label this bucket. So let's say name of this bucket is, let's say X. Okay, name of the bucket is X. So this whole bucket in which we are storing a value and we are referring it with a particular name, this whole thing is called as a variable. This whole thing is called as a variable. That is, you have to create some bucket inside the memory that can store some value, and that will be having a particular name using which we will be able to refer to it, that we are referring to this variable, right? So variables are memory buckets that stores our values and has a name as well, right? And has a name as well. So if let's say in your piece of code you want to store the information 12, or let's say you want to store my name as the information, what you will be able to do, you can just create a bucket, name the bucket, put the value inside the bucket, and you will get a variable. So this whole bucket is called as a variable, right? So inside variables we will be able to store data. So inside them we can store data, as simple as that. Now we have to think that how to make variables in JavaScript and how they actually work. Variables can actually hold your data. How to create variables in JavaScript we are going to discuss in some time. But first of all, try to understand the concept of variables. Variables can hold your data. It is like a bucket in the memory that has been allocated to you inside RAM. So let's say your process has been allocated 512 MB of memory. So this bucket will be part of that memory, that let's say 10 MB of that memory this bucket took. Inside this bucket you are going to store some value, let's say for example 12, or sorry, let's say some example 12, or let's say some text you want to store, or something else you want to store. We'll see what different type of things we can store, but something you want to store. So what you can do, you can store it and you can give a name to the bucket, or you can say you can give the label to the bucket. So this is the label, this is the value, right? So using this label we will be able to refer to the variable, that what is the value present inside the variable, or if we want to update the variable, that thing we are going to discuss. But for the timing, just try to understand that variable is a bucket that can hold some value for you in the memory. Now in your computers you might have seen a lot of files, you might have seen images, you might have seen music files, video files. Let's say you have an image, a lot of image, you might have seen the file name as some image.jpg, some music files as music.mp3, right? Video files as .mp4 or .avl. This dot something is called as extension. So we are going to create a JavaScript file. We are going to create a JavaScript file. So how to create a JavaScript file? The extension of JavaScript file is .js, right? If let's say you have to create a PowerPoint file, so you create .ppt, right? pptx or .ppt. If you have to create a MS Word doc file, so you see you put .docx or .doc. If you have a PDF, you do .pdf. So similarly, if you have a JavaScript file, so the extension of the file is going to be .js. This is going to be the extension of the file, right? This is going to be .js. Okay. So let's say if I have to create any JavaScript file, I can give the name of the file, for example index, and then I will put .js. Any other name, let's say demo.js. So file name can be anything, just like in your computer you can have any name of your file. So you can say demo.js, index.js, things like this, right? That being said, what you can do is, here you might be able to see an option of new file where your folder name is mentioned at the same spot. See, here your folder name is mentioned. Just to the right of it, this is the option of new file, right? This is the option of new file, right? Just click on it. You will be able to see a pop-up here and create your first file. You can create your first file. Okay. So we can say variables demo.js. You can name the file anything. You can name the file anything. And you can write variables demo.js. You can write index.js. You can even write your name, doesn't matter. And just press enter. And just press enter. And by pressing enter, you will be entering into a JavaScript file. So this is a file where we will write JavaScript code and it will understand the code automatically. Now, in order to run JavaScript code, we can do a lot of things, right? Because we are in the initial stage of the JavaScript, we don't want to go too much technical, right? So how we can run a JavaScript code? Now on VS Code, in the left side, you will be able to see a lot of options, right? You can see a lot of options. For example, this extensions, run and debug, source code, right? These options you will be able to see. Click on this option of extensions. See, this extensions option is coming up, right? So click on this extensions. So you will get kind of like a marketplace kind of a thing, right? Where you can search for some extensions. What are extensions? You can say extensions are kind of like plugins which we can use inside VS Code to make our coding experience much better. Okay. Now what you have to search for inside this search bar, search for code runner. Code runner, right? If you will write code runner like this, see, code runner, write code runner and press enter. You will get this code runner. The icon will be inside yellow dot run, created by this person. The name is also written there, and this is the name, code runner, right? So just write the name code runner and you will get the first option most probably. Just click on it. Just click on it. Okay. I have already installed it, so I'm not getting an option to install, but you might be getting an option to install it. Click on that install button. It will automatically get installed once you click on that button. So click on install and you will get a screen like this. Once you are done, then you can close this window. Like, you can close this code runner window and you can come back to your file. If you have to explore all the files, you can just click on this explorer icon, this one. This explorer icon, you can come back to all of your files. Now, if I talk about the use case of this plugin, if you have successfully installed this plugin, once you install this plugin successfully, you will get a play button. Initially, you might not be able to get it, but once you install this code runner extension, you will get a play button kind of a thing on the top right corner of your screen. Using this play button, we will be able to run our code. Later, I'll tell you that without this extension, how can you run your JavaScript code? But for the initial days, this should be good. Now we know about the fact that inside variables, we will be able to store our piece of information, right? If we create these variables, we will be able to store this piece of information. How can you create these variables? So, how to create variables in JavaScript, right? How to create variables in JavaScript. So technically, there are three ways to create variables. There are three ways to create variables, right? Okay. The first way is using var keyword. Using var keyword. So there is a keyword var using which I can create a variable, right? So what can you do? In your code, you can write something like var, and then you can give a variable name equals to, and then you can give some value, and then you can put a semicolon. I'll talk about this semicolon in a moment, right? So for example, this is the syntax. This is the syntax. For example, you can do something like var. Let me change the color. Var. Let's say the name of the variable is marks is equals to 90. Or you can do something like var score is equals to 5. So when you will write var marks is equals to 90, var score is equals to 5, and if you run your JavaScript code, what will happen is inside the memory, there will be a bucket that will get created. The label or the name of the bucket will be marks, and the value stored inside will be 90. Similarly, one more bucket will be created. The name of the bucket will be score, and the value stored inside will be 5. Right? You can store different values in variables. What different values you can store, I will tell you, but this is one of the ways to create variables, right? So if I write this piece of code, we can do something like var player name is equals to Sanket, or for the timing, let's keep things even more simple. Let's say var score is equals to 10, or maybe something like var marks is equals to 90. Okay, currently I am storing only numbers, but I will in a moment I will tell you that what different things you can store. Okay, so this is the first way in which you can create variables. Now the second way is using let keyword. So how can you use the let keyword? If I talk about the syntax, then you can write something like let, then you can put a variable name, again name of the variable, equals to a value and a semicolon. For example, you can write something like let age is equals to 24, right? Or let flag is equals to 0, something like this. So this is going to do a similar thing. In the memory, it will create a bucket. It will create a bucket. Label of the bucket or the name of the bucket will be age and the value stored will be 24. In the second case also, it will create a bucket. Name of the bucket will be flag and the value stored will be 0. Right. So this is the second way to create variables. Let me show you. So you can say something like let age is equals to 24. Let flag is equals to 0. Okay. This is the second way. So what are the two ways? The first way is you can use a keyword var. Keyword means it is reserved for JavaScript. So you can write var in all small letters. Then you can put the name of the variable. You can say equals to, and then you can say the value of the variable. Same thing like this here. The second way is I can write the keyword let, and there's a space. Then I can name the variable equals to value of the variable, and then you can put a semicolon. Same thing here. So these are the two ways in which you can create a variable. So guys, you might get some I would say confusion about what is var, like what happens when you write var. So var is like an instruction for the timing, right? It's a keyword. It is something reserved to JavaScript. That means JavaScript knows about it. So when you write var, you put a name, you put equals to, and you put a value. That means you are giving JavaScript an instruction that please create a variable with the name marks and a value 90 in the memory. So you are instructing JavaScript to do something. Same thing with let, that this is an instruction to JavaScript that you have to create a new variable in the memory. Now there is some, now you might think that, okay, if they both of them are doing the same thing, why we have a var as well as a let? Why we just have one solution? So later when we are going to learn about scopes, you will understand that what is the difference between var and let. You will understand this concrete difference properly. Let's just quickly talk about the third way. If you talk about the third way, then you can use using const keyword. Using const keyword also, you can create a variable in the memory. So you can write something like const, then a variable name equals to, and then a value and a semicolon. For example, you can write something like const x is equals to 100, something like this. So if I try to code it, const x is equals to 100. Okay. These are the three different ways in which we can create variables. Now you might get a lot of question in your mind. You might get a lot of questions in your mind that can I name the variable anything? Or what is the use of this semicolon? Do we need to put spaces always and everything? So we are going to talk about this. These are more around the semantics or the grammar. We are going to talk about this, but for the starters, there are three ways in which you can store some data in your RAM using JavaScript. First way is using the var keyword, second way is using the let keyword, and the third way is using the const keyword. Now, if you have to see that whatever code you have written is correct and is giving expected output, then we have to run the code. So currently we have not shown any output to the user, right? We are just creating variables. We are not using it anywhere. So you won't see any output, but if the whole code is correct, you won't see any error also. So how can you run the code? What you can do, once you would have installed Code Runner, you will see this run code button. Click on this run code button. The moment you click on this run code button, you will see something like this. If you are getting an output like this, then everything you wrote was correct. If you get an error, then read that error, what that error is telling, and you will be able to rectify it yourself only, because JavaScript errors are significantly verbose. You will be able to understand them, right? So just click on this run button and you will be able to run it. See, click it running and done, because we are not showing any output to the user, so nothing is coming up. Repeating, guys, whenever we will change any code change in the file, VS Code, you will see this circle here. You will see this circle here. See this circle, right? Once you will save the file, this circle will turn into a permanent cross. This shows that you have saved the file. So maybe you made some changes, but you didn't save the file. So you won't be able to see those changes, right? So make sure you always save the file. Once you have saved the file, run the file again, and you can see currently there is no output, but there is no error also. So everything is working fine. Now a lot of question might be coming in your mind that let's say we are creating variables and we are giving names. Can I give any name? Can I give any name? Right? What about this semicolon? Let's talk about this. Okay, let's talk about this. So what about semicolon? What about semicolon? Right? So when you write one line of JavaScript code, let's say you write one line of JavaScript code. This is equivalent to, this is equal to one instruction that we want to give to the computer, right? When you write one complete line of code, that is equivalent to saying one instruction that we want to give to the computer. For example, when I wrote var score is equals to 10, this is one instruction that I am instructing the computer to create a variable score with a value 10, create a variable marks with a value 90, and so on and so forth. So we are instructing, we are giving some instruction. So one complete instruction, let me write it in new line, one complete instruction is called statement, right? When you write one complete instruction, you can say it as it's a statement. Okay, at the end of every statement in JavaScript, we can put a semicolon, but it is optional, right? So when you write one valid piece of JavaScript code, at the end you can put a semicolon, but this semicolon is optional in JavaScript. It is not mandatory. Like if you will not put semicolon, if let's say you don't put semicolon, it will not give you any error. See, if you run the code, let's say I run the code, see, no error, right? So it is optional. There are languages like C++, there are languages like Java, in which this semicolon is mandatory. If you will not put semicolon in a C++ code, you will see errors. But it is not mandatory in JavaScript. But there is a catch. What? If you talk about clean JavaScript code, then think about it in terms of English. This semicolon is kind of like a punctuation mark. So in English also, let's say you are asking a question, and at the end, if you don't put a question mark, no one is going to like harm you for that. Or let's say after a particular sensible sentence, you don't put a comma, then it's not harmful. Like it is recommended that you should use punctuation marks to show the expression of the statement or the sentence that you're writing, right? So punctuation marks are what? Recommended. They are not enforced on you, right? You can write like every valid word will be valid, right? But if you will put your comma, your full stop, your question mark at different places, the meaning of the sentence will change. So it is like a recommended practice. Similarly, semicolon is recommended. That when you have written a complete JavaScript valid statement, one complete valid instruction has been written, put a semicolon. It's recommended. Put it. It's not mandatory, just put it. Why? Because when someone will read it, then they will be able to distinguish between two different JavaScript instructions. We don't write just code to prepare a software. The code should be readable also. Let's say you are working in, let's say, Amazon, and you worked there for like 2 years. So you might have written a significant amount of code. And let's say you left Amazon after 2 years and you went to Microsoft. Then someone will replace you in Amazon, right? And when they will come you, they will come in place of you. They're going to contribute to maybe the same piece of code that you wrote, and they have to read your code also for that. If you will not write sensible readable code, it will become very hard for them to understand, right? So always whenever we write code, we try to write the code is in as clean manner as possible. It's always recommended that you put semicolon. So in throughout the course you will find me writing semicolon after every valid JavaScript statement. Okay, now you might be thinking that can we name the variables whatever we like, whatever we want? Almost, but there are few cases that you cannot put as the variable name, right? So rules for variable creation, rules for variable creation, and technically speaking, naming rules. Like how do you name the variables? These rules are going to signify what is the naming rules. Okay, so the first rule is variables can contain small alphabets, capital alphabets, right? So in your variable name, you can have small alphabets, capital alphabets, digits, right? You can have anything from 0 to 9, like you can have something like play 001, something like this. Okay, digits, right? You can have underscore, you can have underscore. So how underscore looks like this? Underscore looks like something like this. In the blue character, this is underscore, right? Don't confuse it with the minus or the hyphen sign. It's underscore. So if you will press shift minus, then you will get underscore most probably on your computer. This is underscore, right? So this is hyphen, but if it is landed on the ground, this is underscore, right? So you can have underscore, you not hyphen, underscore. You can have underscore, and right, these things you can have, these things you can have. Secondly, we cannot have, we can't have space or any other space or any other special character, right? For example, you cannot have something like first space name as a variable name. No, this is not allowed. This is going to give you an error. You cannot have spaces, right? You cannot have hashtag, you cannot have ampersand. These things cannot do not qualify to come inside a variable name. Okay, the only special characters that are allowed is like small alphabets and capital alphabets are not special characters. These are like alphabets. Digits are allowed, underscore are allowed, is allowed, and one more character, dollar is allowed. Dollar. This dollar character is also allowed. Apart from these, no other special characters are allowed. Right. Third thing. So we cannot have space, we cannot have hashtag, other special characters are not allowed. Right. Apart from that, uh, let's see. We should give meaningful names, meaningful names, so that reader can identify the names properly, right? So whenever you will be writing code in production level software also, even if you are writing code in your interviews, at any point of time, you should always make sure that whatever variable names you are giving, those variable names should be having some sense. It should not be like anything random that you are trying to create, right? It should always have some sense. So you should always give meaningful names to your variables. One more rule is variable name cannot start with a digit. Cannot start with a digit, but it can have digits in between or at last, right? So we cannot even start a variable with a digit. For example, if you do something like let 0 James is equals to 10, this is a wrong syntax. This is a wrong syntax. Okay, this is a wrong syntax. So you cannot have digits in the start, but you can have digits in between, or you can have digits at the last, right? Fifth rule, we cannot use keywords as variable names. We cannot use keywords as variable names, right? You cannot name a variable like, let's say, let or const, or like other keywords like for, if there are other keywords also. You cannot name a variable with a keyword. Okay, these are some of the naming conventions that we need to follow while creating a keyword. So let's see some cases where these naming conventions are not going to work. So I'm creating a new file, invalid variables.js, right? For example, if you try to do something like const first space name is equals to, let's say, 10 for the timing. So you see, it is already throwing the error. See, it's already highlighted. It has already highlighted it with red that there is something wrong with it. Okay. Apart from that, if you do something like 3 address is equals to 23, for example, see, again error. You cannot do something like this. Like, you cannot start a character with digit, but you can have digit in between. See, this is fine. No error throwing up. You can have underscore anywhere. Like, you can even start with underscore. See, everything is fine. You can have underscore in between. Everything is fine, right? You can even use dollar. See, looks fine. But let's say if I try to use something else, for example, let's say percent something. See, error, right? So we have to always follow naming conventions. Right? If you just put a digit, then also it is, because if you just put a digit, that's the only thing. So it is not going to work as well, right? So we have to always follow the naming convention. I'm just removing all of these because all of these are going to throw error. Now, we have created some variables. We know about a bit of naming conventions. But how can we actually show this information to the user that in my code, this is the value of a variable? Or let's say we want to show any piece of information to the user. We want to show some piece of information to the user. This can be our variable. This can be something else also, right? So in order to do that, we have a concept of functions. Functions we are going to discuss in very in-depth also later when we will start with functional programming. But for the time being, you can assume functions as a black box. For example, let's say you go to a bank. And you want to deposit 100 rupees to your account. What do? If you want to deposit 100 rupees to your account, then you just go to the bank. There is some steps that you have to follow, right? For example, you have to fill a slip or something, and then you go to the cashier. You give that slip and your 100 rupees to the cashier, right? Now, what cashier does with it, you don't know. You cannot see their screen. You don't know finally at the end of the day where he or she is going to put that cash. right? So that piece of information is abstracted out. That means you don't know about that piece of information. You don't understand about that, right? This is the concept of functions. So your bank cashier is like a function. He or she is like a black box to you. You don't know how they work. What you only know is they expect some input from you. They expect that you will bring cash to them and they will give you a slip out of it. They will give you a receipt out of it. That will be an output. That's the same for functions. So what functions does is they take some input, they take some input, they process the input somehow. You don't know how, right? You never asked your cashier, right? That what you're going to do with this 100 rupees, where you're going to put it? No, right? You just go to the bank and take the receipt and you are assured about the fact that these 100 rupees are going to go inside your account. So that 100 rupees is your input, along with the slip is your input, and the receipt is your output. Same thing for functions. Every function can do some task for you. How they are doing it doesn't matter. How they are doing it doesn't matter. Functions can do some task for you. They are like a black box. You don't know internally how they work. All you know is they take an input and throws an output after processing. Right? This is the concept of basic functions. This is the concept of basic functions. Now, now we know that what are functions. In functions, we don't know how the function works, but we know what the function works. So similarly, the first function that I want to introduce is one of the inbuilt functions. That means JavaScript gives you a lot of functions by default that can do a different things for you. We are going to slowly and steadily throughout the course learn about them. You can also build your functions that we are going to learn in functional programming. But the first inbuilt function that JavaScript gives you and you can use is console.log. Console.log. What is console.log? This function takes some data as input and then displays in the output and displays them in the output. So what console.log will do? Console.log function is actually going to take some input and whatever is the input, it is going to display them. So generally how a function looks like? A function looks like something like x comma y something something and it does some task or give you some output, right? So similarly, console.log can take multiple arguments, right? Now these arguments can be anything. You can pass 10, so it will print 10 on the screen. So let me show you. Let me demonstrate console.log in front of you. Console log demo.js. So see, I'm creating a new file, console log demo.js. So you can do anything. You can do console.log 10. What it will do? It will display 10 on the screen. If you run it, see, now it is showing 10 on the screen. Let me run it again. See, it is showing 10 on the screen. Can I say that? You can even put a text, right? How do you put a text? You can open a double quotes and write hello world, right? I'm going to discuss more about this text later. So if I run this piece of code, see, in the first line we are getting 10, in the second line we are getting hello world. In fact, you can even create some variables. For example, in let age is equals to 10 and I can do console.log age. So you can even pass the variables, right? So you created a variable here. See, let age is equals to 10. That means in the memory, you created a bucket, you stored the value 10 there. Name of the variable is age. Now, if you want to refer to that variable, that means use that variable. So what you can do, you can just use its name now. If you don't have a variable and you are trying to use it, it is going to give you something else. It will give you undefined. Later you will realize why. But for the timing, just understand that if you create a variable and you give a variable name, it will display the variable value. See, 1 second. Let's run it. See, 10 hello world 10. So the third 10 we are getting due to age. Let's make the age as 13 for distinguishment. See, 10 hello world 30. So you can give different type of inputs to console.log. Its only task is to display them on the screen, right? Now, one very interesting part is you can even pass multiple values. So now what you can say is, if we have two different console.log, then both of them displays slash prints output in different lines, right? You can even see that. When I have three different console.log, they are printing in three different lines. Whereas we can also pass multiple values. Together to console.log, right? And all of them will be on same line. For example, you can do something like this: console.log 10 starting, let's say you have a variable let age is equals to 23. So you can pass age, right? So what you can do, you can pass comma separated values. Let me show you. So what you can do here is console.log, you can pass comma separated values. For example, age, then you can pass, let's say, some number 343. You can pass some text, some random text. You can pass more numbers, 45, right? So now you can see I have passed these four different values, comma separated, everything is separated by comma, in one console.log. So if I run it, you can see these four values are coming in same line, space separated. Everything is separated with a space, right? But if you put different console.logs, it is going to print in different lines. For example, console.log 10 and console.log hello world are two different console.logs. It is going to print in two different lines. If you want to put in same line, you can see you can put multiple values comma separated, and that will give you everything in the same line. Now, what type of data you can store inside JavaScript? We are just currently in the variables, we are just currently storing integers, like kind of like numbers. But what different variables, or let's say what different values you can store inside JavaScript? What all values we can store in JavaScript, right? So the most accurate answer you will get from the official documentation of JS. What is a documentation? You can say that the people who contribute in the development of JS, who release new version of JS, they write a big set of documentation where they write all the features of JavaScript very in depth, right? So I would like to show you a piece of documentation. Just a second, let me load it on the screen. Also, just for a fun fact, MDN is not the official JavaScript documentation. It's documentation written by Mozilla. Official JavaScript documentation is given by ECMA International. Let me show you. Just a second. The second guy is loading the page. It's a heavy page, so it takes some time to load. So now this is the official documentation of JavaScript. So it's talk about ECMAScript data types and values. So as I already told you that JavaScript was earlier called as ECMAScript. So documentation is still released as ECMAScript, right? If you see the ECMAScript language types, So it says that ECMAScript language types are undefined, null, boolean, string, symbol, number, object. Quite a few, right? Let's see. So in JavaScript, the most basic thing that you can store is number. For example, number like 10, -3, 2.6 decimal is also considered as number here. 3.41414, 100, 1000, right, etc. All of these are numbers. You can store numbers, right? The second important string thing that you can store is string. Now there is a lot of things to learn in strings. Currently I'm just introducing strings, but later we are going to discuss a tons and tons of things around strings. So strings are simply text. So what you can do, there are two ways in which you can have strings, technically three ways. One is you can have a pair of double quotes. This is like double quotes. Okay, you can have a pair of double quotes, and inside double quotes you can write any random text. For example, my name, Sanket. So this is to signify text. Let's say you have to write a long text, right? That's not a number, it's a text. So you have to write text as double quotes. Inside the pair of double quotes, you write the text. This is one way. Another way is you can even use single quotes. You can even use single quotes. Inside single quotes also you can write a random text. Random text. Okay. This is the second way. Third way is you can use a backtick. You can use a pair of backtick. So I'll show you what keyboard character is a backtick, but inside backtick also you can write some text. So texts are said to be as string. It's a general programming term. Wherever you hear the word string, that means we are referring to some text. Okay. So if you want to see backtick on your keyboard, right, then let me show you what key is a backtick or a backquote, right? See, something like this. This is a backtick, this small one, this small one. The upper one is, the upper curvy one is a tilde. The one which is below is a backtick. Okay. It is generally below escape. It is generally below your escape. Okay. See, generally along with tilde you have it. Let's see. Let me see if you have any general computer one. See here also. This one along with one. To the left of one, this character below the curly one is a backtick or a backquote. Right? Backtick or a backquote. The double quotes, where are the double quotes? Let me show you the double quotes. So the upper one here, these are the double quotes, right? And below them are the single quotes. See, single quotes. So you can see single quotes are like kind of like forward, whereas back quote is like backwards. Okay. So using these three things, you can create strings, right? So first thing that you can store inside JavaScript is number. Second is string. Okay. Third thing that you can store, which is kind of very important, is Boolean. Now, what is Boolean? Now in your elementary 10th 11th classes, you might have heard about boolean logics and boolean gates and everything, right? So boolean means true or false, true or false. So you can have true or false, right? True or false. These are technically keywords only. So these are the keywords that represent a boolean value. True means the, like in boolean circuits, true means current is going through, false means current is not going through. We have a boolean value to signify a situation of 0 1. Boolean generally means 0 1. Whenever, let's say, we have to say that is it raining, so it can be a true value or a false value, right? So computer talk a lot in terms of true, false, or 0 1, right? So make sure true is all small, because it's a keyword. You cannot like change the characters. This is all small. False is also all small. These are all small values, right? All small values. Okay. And again, are keywords. Fourth thing, fourth thing is undefined, right? Now, undefined is also a keyword only. Undefined is also a keyword only. Undefined is generally used to represent something that has not been defined yet, but may be defined later. Something not defined yet, but may be defined later. For example, let's say you have a login logout page. I'm just giving a random example. Let's say you have a login logout page. By the time user is going to enter an email, like, or let's say before the time the user actually enters the email and password, the email and password field are kind of like empty. So they are like undefined. They can get a value in future, but currently they are not having any value. So it's like undefined, right? There's like an advanced concept of being undeclared and undefined, but we are going to come to that later in scopes. But for the time, you can say that it is undefined. It is like a type. It is like a type. It's an option. You can, now a lot of people can say I can also define uh, uh, instead of undefined I can do something else. Yes, you can do something else, but it's like a convention. It's like something that JavaScript gives you as a feature, that if you want to have a situation where you have not defined something, but let's say later maybe you want to define something, you can use undefined, right? Something which is currently not present is can be used as undefined. Okay. Numbers, like if let's say you want to store the scores of the players, you can use numbers. If you want to uh, store the name of the players, you can use strings. If you want to show the situation of the game, whether the game is ended or game is going on, so you can use boolean, right? So using these different type of variables and their values, we can actually do this. For example, let's say if you want to store a number somewhere, oh, one second, let me just close this. If you want to store the number somewhere, you can write something like where x is equals to 10. Okay. If you want to, let's say, store a string, you can say where name is equals to Sanket. If let's say you want to store a boolean, you can say where condition is equals to true. If you want to store undefined, you can say where status is equals to undefined, right? Just write undefined all small, just write undefined all small, right? This is how you can like even create the variables. So the next important data type that we are going to have is going to be, like, we are going to discuss about it in very much in depth later in the course. Also there will be dedicated lectures specifically on this data type, but this is the fifth important data type, that is objects. that is objects, right? So let me open once again in front of you the ECMAScript language doc, right? So if I just quickly open ECMAScript documentations, right? Just a second, let it open. Okay, so let's go to data types and values. Just a second, let's go to data types and values, and you can see. So undefined we have talked about, string and boolean we have talked about, number we have talked about. The next important one is object, right? Next important one is object. So let's talk a bit about object. Although object is a very big topic in itself, a lot of things are going to be discussed about objects. But for the time being, you can assume that if we have to somehow store key value pairs, key value pairs, then we can use objects, right? So not only in JavaScript, but some other languages like Python and all, and a lot of languages do support this kind of a behavior where if you want to store key value pair, right? Key value pair, for example, let's say you want to store something like a key, and corresponding to a key you want to store some value. For example, let's say you want to store name, and let's say the name is Sanket. Okay, then let's say you want to store something like company, you want to say something like Google. Then let's say position, then let's say you want to say something like software engineer, right? And these values are of course kind of like a text, right? So let's say if you want to store a structure like this, if you want to store a structure like this, something like this, where we have key and corresponding to the key we have value. So this structure is called as an object. Let me give you one more example. Let's say another example can be, let's say name is Sarthak. Let's say company is PhonePe. Let's say position is APM, right? So this can be another example. This can be another example. So whenever we have to store something like a key value pair, right? Keys are going to be unique. Keys are going to be unique. You cannot repeat the keys. Keys will be unique, right? So if you have to store a structure like this where we are storing key value pairs, in different situations we can have different key value pairs. For example, by just using a number or just using a string, we might not be able to define a complex entity like person. Let's say you are building the next big social media network, right? So you might have to store the data of a user. I'm just giving you a hypothetical example, right? If you want to store the data of a user, now you can't just define user with just maybe a name, right? User has a lot of things. User has a name, user has an email address, user has a password, user has some, let's say, contact information. A lot of things for just one user you have to store. How can you do that? So things like objects come into the picture, where if let's say this is somehow somewhat user one, this is somehow somewhat the user two, right? So if you want to store some complex entities where you are storing more than one property, and based on more than one property you create one complete entity, that you can use or that you can store using objects, right? So let's say, let's take one more example. Let's say I want to store a product. So product will be having a lot of properties. Let's say product will be having a name. We can define the name of the product as a string. So see, I'm going to use a string which is already a data type to form the name of the product. So let's say iPhone. Then let's say I will say something like cost. So you can say 1,30,000. Right? This can be a number, not a text. This can be just a number. Right? Then let's say you have a property color. So let's say deep purple. Right? Let's say you have a property discount. Let's say 5. We are going to display discount in terms of integer, that much percentage or number, that is of some percentage. Right? Let's say there is going to be some description of the product. Right? This description can be the new Apple iPhone. Something like this. So this is going to be a complex entity. In order to show one complete product, you need multiple things. See, we are using a number also to denote a cost. We are using a string also to denote the name. So other data types we are still using, but using these other data types, we are building a complex entity. This complex entity, where we are storing things in the form of key value pairs, key value, key value, key value, is an object. So wherever we have to store a situation, or wherever we have a situation where we have to store key value pairs, where we can show complex entities, that's going to be done using a JavaScript object. And these objects are going to be of quite some relevance in your development journey as well, and when you are going to do data structures and algorithms, then also object, right? So when you say that an object is formed by combining multiple simple properties, then just think about it. If you want to create an object, then these key value pairs are somehow somewhat going to be of some numbers or strings or maybe some boolean, right? Something like this. But to define a boolean, we don't need anything else, right? If you want to define a boolean, that's a boolean, true, false. Boolean doesn't depend on a number. A number doesn't depend on a boolean. A string doesn't depend on a boolean or undefined things like these. Can I say that? So the simple properties, these simple properties are defined by types called as primitive data types. So here there is a fun fact and a new knowledge that I'm going to give you, that there are two types of data types: primitive and non-primitive. What is primitive? Primitive means which are atomic in nature. Types which are atomic in nature. Types which are atomic in nature. Atomic in nature means that they doesn't depend on anything else. For example, numbers. If you have to define a number, you don't need a string, right? So they are atomic. They can exist themselves. They can exist themselves. Whereas if you talk about a non-primitive, so types which are a composition of other types. Types which are a composition of other types. For example, object. So to create an object, we have to use other properties or other primitive data types as well. And fun fact, and let me give you one fun fact. So let's say that I am defining the next big Facebook, maybe something like that. So let's say I am having a user data. In my user data, let's say I'm having name of the user. So let's say name of the user is Sanket. Then let's say I'm having age of the user. So let's say my age is 24. Let's say I'm having something like posts of a user. Now, a user can make a lot of posts, right? On facebook.com, twitter.com, you make a lot of posts, you make a lot of tweets, right? Now, you cannot just simply define a post, right? Or you cannot just simply define a tweet. This post can be a complex entity, right? Because this post can have different piece of data. Now, this post can be an object in itself. For example, there will be a creation date created at, so some date, let's say June 12th, 2022. Then there will be some text of the post that, let's say, my first post, something like this. I'm skipping things, only two properties, that when this post was created and what was the text of this post, right? And there can be a lot of such posts. For the timing, I'm just keeping one post just to demonstrate things. Then let's say I can have more properties. For example, let's say gender. I can have a gender property. Let's say that male, right? And so on. So now you see why I am calling objects as non-primitives, because object depends on other types. Inside an object, you see you have a string also getting used, you have a number also getting used, and you have an object also getting used. So you can have an object inside an object, right? So this level of nesting, this level of complexity you can introduce. Although in the initial days of programming, you don't need to do these much things, but later when you will start learning development with JavaScript and everything, these kind of structures are going to be quite relevant for you. So that's why we have objects, where we want to define much more complex entities that are not just numbers or strings or boolean, but they are going to be a complex composition of simple primitives and even sometimes internal objects also. That's what that is what the difference between primitive and non-primitive data types. So if you talk about the next data type that we are going to discuss, it's null. It's very controversial, to be very honest. In other languages apart from JavaScript, like I've learned a lot of languages. I have worked with Python, I've worked with C++, Java. But this interesting case occurs only in JavaScript. Because to be very honest, JavaScript as a language in the history, throughout the history, they have made some mistakes, but they have done some very crucial things also for programmers. They have tried to touch each and every possible corner case. So if you hear the word null and if you hear the word undefined, this is an image that demonstrates the difference very easily. I got this image from one of the Stack Overflow articles, right? So if you hear the word null and if you hear the word undefined, then both of them gives you a sense of emptiness. If you remember what I taught about undefined, something not defined yet, but maybe defined later, right? Something not defined yet, but maybe defined later was undefined, right? Now there is something new in the picture, null. If I say something not defined yet, but maybe defined later, it's kind of a sense of emptiness. And to be very honest, null also gives the sense of emptiness. So what is the difference between null and undefined? Null and undefined. So let's talk about null. So when you say null, right, it actually represents empty value. It actually represents empty value. If you have the sense of actual emptiness, that is actually shown by null, right? Whereas if you talk about undefined, undefined is a value that has not been given a value yet. It was never given like even not even an empty value. Like empty can also be considered as value, like nothing can also be considered as value. But if you have never given it a value, that's undefined. So if you look at this image, so this is an example. The user has taken the example of a toilet paper roll. So let's say if this roll is still having paper, it is definitely a non-zero value. The roll is still having paper. If this roll is now having no paper, then this value is 0. But just think about it. If you don't even have the roll, if you don't have the roll, if you don't have the roll, you can't have the paper. So now I can say that this is a null value. This is a null value. But what if there was no holder altogether? There is a holder, right? This is a holder. This is a holder. If there was no holder, then there can never be a paper roll inside it, right? So this holder is also actually completely gone. So we can say that in this wall space, somewhere down the line, maybe there can be a toilet paper holder that will hold a toilet paper, or maybe there will be some switch, or maybe we'll post something, anything. So this particular wall space has never been given a value, but it might be given some value later. Whereas here you can say that this holder is in place, but the role is missing. If the role is missing, that is this particular role. If the role is completely missing, then there won't be any paper. So it's three layer, right? There is a holder, there is a role, and then there is a paper. If there is a holder, then definitely sometime down the line, only one thing can occur in this wall space. That is a toilet paper roll. Currently, there is no toilet paper roll. That's okay, but it cannot be like now moved or shifted somewhere, right? When you put inside this holder, if you put a roll that is not having a paper, that means paper got exhausted. That can represent a zero value. And if you have a paper, that can represent a non-zero value. Long story short, there are two data types to give the sense of emptiness: null and undefined. If you go with other languages, like Java, C++, they just have null. They just have null for most of the cases. But here in JavaScript, we have one more case handled. Like if you go with something like C++, then null is going to define both of these cases because they have not differentiated things so well. But if you go in the world of JavaScript, they have differentiated things very well. So this kind of a case is going to be handled by null. This kind of a case is going to be handled by undefined. Undefined is, let's just think, if let's say you say something like let a, if you say a variable let a, now I have not given this variable any value. So never it has been associated with any value. So currently it is not defined. That means it will be undefined. I'll demonstrate with code also, but this will give you the value undefined. Whereas I can do something like, let's say we were having some value b is equals to 10, and now I want to just vanish this value. I can say b is equals to null. So b more or less gives the impression of empty value, that the value is now empty. Let me show you with a coding demonstration so that you can even see that actually this gets printed in JavaScript. So what I can do, like you guys already know that we have to create variables. We can create variables in different forms. So let's say if I do something like var marks is equals to 100. Then let's say if I do var name is equals to Sanket. Let's say if I do var age and I'm not giving age any value. If I do var company, let's say I put a value null like this. If I let's say put var is equals to salary, I can even put undefined. Let's say var is a student, I can give it a value false. Okay, something like this. Now let's try to print all of them. Let's try to print. So I'll say marks is equals to comma marks. Right, let me try to print all of them. Then let's say name is equals to the variable name. Age is equals to age. Company is equals to company. Salary is equals to salary. And is a student equals to is a student. Okay, let's say I'm trying to define kind of like a person or a user somewhere, right? So I have created a new variable marks. I can create variables with var, let, const, all of three. In the initial days, most of the time we'll be using var or let only. Later when we will learn scope, we'll try to understand the actual differences. So I just created all of these values. Let's try to run it. How to run it? Let's just press on this. And you can see all of these values are getting printed. Now let's see one by one. We say marks is equals to, marks is equals to, and the variable that I'm trying to print is marks. What is the value of that variable? 100. It's a number. It's a number. So see, 100 got printed. Name is equals to name. So it's Sanket. It's got Sanket printed. Age is equals to age. Now see, I have not given age any value. It has never been given any value. So it gives you a sense of being undefined, and you can see it prints undefined. It prints also undefined, right? Why it automatically got undefined? Like for the timing, you can just understand that a variable that has not been given a value will automatically get undefined. How it gets it, like the process of giving the value undefined is going to be learned in lexical scopes part. That's going to be coming up later. Now let's say company is equals to null. So see, you are able to print the value null. You are able to print the value null. See, it's not a text. I have not wrapped it inside double quotes, single quotes, or backtick, right? It's a separate entity. You just write NULL. It's a keyword. JavaScript recognizes that it's a keyword null. That means you want to store a value null inside this variable. And this is one way to create undefined variable. Otherwise, you can even manually give the value undefined. That currently nothing has been given to it, so I'm just giving it undefined, right? So you can even manually give undefined and see undefined is getting printed, and you can give false also. So false is getting printed. But you can see, right? To define all of this looks very complex, right? Looks very complex. How about if I want to define something like a user, which has a complex set of values? So we can do this using objects. How do you create an object? So just like how I created an object here, you have to put a pair of curly brace. You see, pair of curly brace, pair of curly brace, and here also you can see a pair of curly brace. So you'll always put a pair of curly brace, and inside the pair of curly braces, you will do it. So let's say name, Sanket, company. You say Google, and let's say age 23, 24. Right? Let's keep like this. And let's say if I do console.log details of the user is, let's print the variable user. See, name of the variable is user. Let's try to print it. Let me clear the console. Right, let me put it like this. Let me expand a bit. And you can see details of the user is, and can you see it is printing it in the same manner? Name, Sanket, company, Google. So in this one complex entity, I have defined one user. In this one complex entity, I have defined one user. So how do you define an object? You put a pair of curly brace. You put a pair of curly brace. See, here also you put a pair of curly braces. Then you put a key. You put a colon and you put a value. And then you put a comma. Then again a key, colon, and a value. Value is going to be some valid JavaScript type. And a comma, comma, comma. After every key value pair, you have to separate it via comma, right? So see, I've separated it by a comma, and that's it. I will print the user and I will get a user. So when we have to define complex entities, you can use objects also. So we have demonstrated most of the data types that we have learned till now. Before we move ahead, there is one very interesting thing that we should talk about. That is, in programming, in almost most of the languages that at least I have worked with and I have at least heard about them, there is a concept of special characters. Right. What are special characters? Just like A, B, C, D, 1, 2, 3, 4, you have these digits as the characters and all. Now on your keyboard, you have a character, like you have a key of enter also, right? Like using which you can go to a new line. And you have a key of tab also. Tab is not a space, right? It's like four spaces together makes a tab, let's say, in your system. So tab is also a key. A new line is also a key, right? Using which you go to a new line. So let's say if I define a text. Now I want to define a text like the new Apple iPhone has been launched. Right, something like this. Like you want to have multi-line text. One way is that you define multiple strings for it. or otherwise somehow somewhat if we can inculcate our enter character, then we can do it, right? So we have a concept of special characters. What are special characters? So if let's say you write something like the new Apple iPhone, and then let's say you put something like a backslash, mind my words, it's a backslash, and then let's say you put a n, okay, backslash n, and let's say then you resume has been launched. So what this backslash n does, it's a special character, right? It is called as, sometimes it is also called as escape sequence, right? So when JavaScript will read it, it will not read it like backslash n, it will read it like a new line. This is considered as a new line character, new line character, right? Wherever, if you like, if you are making a text, I'm talking specifically about text strings. Inside a string, if JavaScript at any point of time reads a backslash followed by a n, it will treat as a new line character. If let's say it reads backslash t, it will consider it as a tab. Let me show you. So special chars .js. If let's say you make a variable let text is equals to the new Apple iPhone, and let's say you put a backslash n, see, there is no space between the backslash and the n. Both of them are together. And remember, this is a backslash. There are two slashes in your computer system, backslash and forward slash. It's a backslash, okay? So you put a backslash n, and then you put, let's say, has been launched. And let's say I try to print this text. Let's say I try to print this text. And if I run it, see, it went into a new line. So what exactly happened? It is going to consider it as a new line character. Now after the new line character, you see you have a space here also. So you can even see that space here. So it's like wherever you see a backslash n, at that same moment, JavaScript just kind of like will press enter. It will look like it just pressed enter for you because it's a new line character. If I replace this backslash n, let's say, if I replace this backslash n with backslash t, let's say this time I write iPhone 14 has been launched. Now if I console.log it, x2, and run it, see, now there is a tab space, like there is a space of a tab, like multiple spaces, most probably it looks like 4 space. So there is a gap of a tab between the 14 and this starting space, right? So that's what special characters are. So there are a lot of special characters. So you can just read about special characters of JavaScript. So special chars JavaScript, you can read some good articles, right? See, some article is coming up. So you can read about all of these special characters. Let me just search for it, backslash and see. There are a lot of ones. Now you might be thinking, right? If let's say whenever I write backslash and I write a n, it treats it as a new line. But what if I have to print backslash, just a backslash? How do you do that? So for that you have to do double backslash. If you do double backslash, it will print one backslash, something like this, right? If you have to do something like a backspace, you can do slash b. You can just read about it. Generally in your programming career, you are going to use backslash n and backslash t, and mostly backslash n. So that is going to be something that you can use, right? So backslash n can be used to print something in a new line. So let's say now if you have, let's say let age is equals to 10, and let's say let name is equals to Sanket, and if I do console.log, let's say I print Sanket, then I print a string backslash n, and then I print age. Now I am assuming what will be the answer? You will get Sanket, and then you will get age in the next line, because in between you tried to print a enter character or a new line character. So this is about special characters in JavaScript, and these special characters are consistent in other languages also. So no worries on that part. Now folks, having some basic knowledge about variables, I need to introduce one very important thing to you. Now, you are going to be a software engineer, right? You're learning all of this coding out of your passion to build something new, to build something interesting out of it. Now, you just don't write code for yourself. You're going to write this code for maybe some organization like Microsoft, Amazon. You're going to join there as a software engineer, and you are going to contribute to their code base, right? Or maybe you are going to create your own organization, and in that organization you are going to like have a bunch of fellow software developers, among whom you are going to like contribute to the code base, right? You have to never write a code that is only understandable by you. You never write a code that is only understandable by you. You write a code that is understood by others also. Let's say you leave, let's say you are currently working for like 3 years at Amazon, and you get a better offer at Microsoft, and you like just went to Microsoft. Now in 3 years you would have made a significant amount of contribution. If you have left the place, how will someone understand your code if you have not written it well, right? So we have to write very clean code, and we have to explain whatever we have done wherever we are doing it. For this purpose, we have a very interesting concept called as comments. Okay, called as comments. What are comments? Comments are a piece of code, right? Comments are a piece of code that is for documentation purpose. Documentation purpose, right? Comments are written for documentation, right? Like if someone is reading your code, they can read your comment and understand what the code is doing. The programming language will just avoid comments during execution, right? Let's say our programming language that we are learning is JavaScript. So wherever JavaScript will see any piece of comment in your code, it will just avoid it. Comment is of no use to the programming language. Comments we do write just for the sake of better readability for the people who are going to read our code. For these people only we are going to write comment. This is something very important, right? That we only write comment for the sake of documentation, for the sake of readability, right? We don't write comment for JavaScript. The moment JavaScript sees a comment, it will just avoid it. It has nothing to do with the execution of the code. How do you create comments? In JavaScript, in JavaScript, there are two ways to create comment. There are two ways, right? If you have to create a single line comment, single line comment means, let's say you have to just write the comment in a single line. What you can use? You can use double forward slash. Double forward slash. Right. This is something that you can use. If you have to create a multi-line comment, that is, let's say you have to write a lot of things, you have to explain a lot of things, and you have to write a multi-line comment, then what do you have to do? You put a forward slash, then you put a star, right? And then you put multiple lines, and at the end you put a star and a forward slash, right? So let me show you the demonstration that will help you to understand things better, right? So comments demo.js, let's say I wrote some code, right? Let's say I'm printing hello world here. Now let's say I want to put some comment, so I have to do two forward slashes. Just put two forward slashes and see the line becomes a bit gray, right? This line becomes a bit kind of like gray, kind of like disabled, right? So here you can write a comment. This is some random comment. Although I'm writing random comments, but when we will be writing a sensible piece of code, useful piece of code, then using the comment, we are going to explain the code. Then let's say we have some more piece of code, hello ending. Then let's say you have to put multi-line comment. How do you put multi-line comment? You put a forward slash, followed by a asterisk, or do you say star? Okay. Then you can put this is a multi-line comment, and you have to close it. You put again an asterisk, and then you put a forward slash. So slash asterisk, then you put multiple lines, and then asterisk slash, and then you can have more lines of code. Finally, if you will execute this file, see, we are only getting hello world, ending, and finally, because what JavaScript will do, JavaScript will just completely avoid it as if there is no comment present anywhere, right? And how do you make a comment? Just put a pair of double slash. This is a console statement, right? That's it. So JavaScript is just going to avoid it. But let's say 2 years down the line, I'm going to come back to this file. And if I read this piece of comments, then I'll be able to understand, right? It's like notes. It's like creating notes that I'll be able to understand that, okay, this piece of code was doing this particular instruction or executing this particular instruction. So how do you create comments? Two ways. Either you can put a pair of double slash and then just put a comment. This is a comment. Or you can put a slash followed immediately by an asterisk, and then you can put multiple lines of comments, and then an asterisk followed by a immediate forward slash. These are the two ways in which you can create a comment. Comment is just for documentation purpose. JavaScript has no relation with comment. It is just going to avoid it. So any programming language can do multiple complex instructions. They can do complex operations, right? These complex operation can be different things. It can lead to something as simple as addition to something as complex as calculating powers, right? Now, these complex operations, like we have classified these complex operations. Some complex operations are for comparison, that whether two values are equal to each other or not. Somewhere we are going to calculate remainders, that can be considered as an operation, right? So few default operations we get by default in every programming language. Different programming language will have one or two variations here and there, but most of the time we get some certain set of operations that are by default given to us by the programming language. And how can we leverage these operations? We can leverage these operations using the concept of operators, right? Operators. So what operators do? These are some predefined operations that we can do in the programming language. Okay, cool. Now let's talk about these operators. So there are different type of operators. There are different types of operators. First is arithmetic operators, right? What is arithmetic operators? For example, plus, minus, divide, multiply, modulo, or you can say remainder. So this plus is for addition, this is for subtraction, this is for division, this is for multiplication, and this is for remainder, right? So these are arithmetic means simple mathematical operations, right? So we have different type of operator. The first type of operator is arithmetic operator, right? Now where do you apply operators? On some operands, right? So there's a concept of operands and operators. Operators is the operation that you want to do. Operands are the values on which you want to execute the operation. So there is a term operand also, values on which we want to do the operation, right? That is called as operand. That is, let's say if you do 10 plus 3, then plus is the operator, 10 and 3 are operands, right? So operator is what? Operator defines what operation you have to do. Operand define on which values you want to do the operation. So if you are defining arithmetic operations, all of these operations require two operands. If you want to add, you will add two values. If you want to subtract, if you will at least subtract two values, right? So these are simple arithmetic operators. Let me demonstrate them in front of you. So operators demo.js. So let's write a quick comment. Arithmetic operators. Okay. So let's see. Let's say we have a value x is equals to 10 and let's say y is equals to 3. If I do console.log x plus y, console.log x minus y, console.log x multiplied by y, console.log x divided by y, console.log x remainder y or x modulo y. So here we are doing addition, here we are doing subtraction, here we are doing multiplication, here we are doing division, and like in division you have two values, right? So this is actually give you the quotient. This is actually going to give you the quotient, and inside this division you are going to actually get the remainder, right? If I try to run this piece of code, let me just, if you want to clear the console, this button you might be able to see clear output. It will just clear the console for you, and now you can run again. So you can see 10 plus 3 is 13, 10 minus 3 is 7, 10 into 3 is 30, 10 by 3, the quotient of 10 by 3 is going to be 3.33333, but the remainder is going to be 1. If you just see the remainder and you don't go to the decimal places, 10 divided by 3 will give you remainder 1. So this is going to be the output, right? So these are some simple arithmetic operators that is given to you by JavaScript. These are the first type of operators, and they just do simple mathematical operations, right? Now let's do one more. Let's say I do y star star 2. Okay. Now let me see if you guys are able to guess what is this operation about. If you run it, you get 9. The value of y was 3. If I do 2 here, it does something like 9. If I put a 3 here, it makes it 27. So looks like exponent, right? So you have one more operator, star star, that is for exponent, right? That is, if you have to do a raised to the power b, you will write something like a star star b. If you will just use one star, that is multiplication, but if you do a star star b, that is power. So these are the arithmetic operators inside JavaScript. Now the second type of operators that we have are assignment operators. Assignment operators. Now as the name suggests, assignment, that means you want to assign some value. So the most basic example is equals to. When you write a is equals to 10, then you are assigning the value 10 to the variable a. So this is one assignment variable. So, but there are few more like plus equals to, minus equals to, star equals to, divide equals to, mod equals to. Now you might be thinking, what are these? Let me give you examples. If you do something like, let's say if you do let a is equals to 10, right? So here this equals to is a assignment operator. What is the use case of equals to? Equals to just directly assigns the value on right hand side to left hand side, right? If on the left hand side you have a valid variable and on the right hand side you have a valid value, it will try to assign the value to the variable. Both of them should be valid. Now let's say if you do something like, let's say you write something like a plus equals to 2. A plus equals to 2. What is the meaning of a plus equals to 2? Plus equals to, a plus equal to 2 means a is equals to a plus 2. It is equivalent to saying a is equals to a plus 2. Now what is the meaning of it? Let's say previous value of a was 10, right? See, previous value of a was 10. Then if you do a plus equals to 2, what it will do? It will treat it as a is equals to a plus 2, right? That means on this left hand side, we take old value of a and add 2 to it, right? So what do? Here you take the old value of a, that is 10, add 2 to it, make it 12, and then assign it back to a, So what is going on? If you do a plus equals to 10, this is equivalent to saying a is equals to, or let's say a plus equal to, let's say just 2. It is equivalent to saying a equals to a plus 2. That means take previous value of a, add 2 to it, then assign this new value back to a. Assign this new value back to a. That means if let's say previously the value of a was 10, you take 10 plus 2, that is 12, it becomes 12, and you assign 12 back to a. So after this operation, if previous value of a was 10, then after this operation it becomes 12, right? So a plus equals to 2 means a is equals to a plus 2, right? So let me demonstrate it in front of you. So let's say now we are talking about assignment operators. So let's say if you do let a is equals to 10, here equals to just assigns value from RHS to LHS, okay? But now let's say if you do a plus equals to 10, okay? So here it is, here plus equal to is actually doing a is equals to a plus 2. So if I try to print the value of a, let's try to print the value of a, okay, console.log a, and let me write a string here also. Value of a after addition is, right, value of a after addition is, let's see, let's clear the console, let's run it. So the value of a after addition is what? 20. So a was previously 10, now you did 10 plus 10, which is 20, and assign it back to a. Let's say if I do a value 7, so 10 plus 7 will be what? 17. So the new value will become 17. So when you do plus equal to is equivalent to saying a is equals to a plus 2, right? Now if this is simple to you, then I'm assuming you might be able to understand what is the meaning of minus equals to. This is going to equal to saying a is equals to a minus 2. What will be the meaning of star equals to 2? This is going to be a is equals to a into 2. A divide equals to 3 is going to be equal to a is equals to a by 3. A mod equals to 3 is going to be equal to a is equals to a mod 3. That is, whatever is the result of a minus 2, assign it back to a. Whatever is the result of a into 2, assign it back to a. Whatever is the result of a by 3, assign it back to a. Whatever is the result of a mod 3, assign it back to a. So let's see. Let's see. So let's say now here I do a mod equals to let's say 3. Okay. Let's do console.log value of a after storing remainder is this, because mod is for what? Remainder. So you are doing a by a mod 3, whatever is the remainder, you are assigning it back to a. So let's see. Let's try to run. So see, previous value of a was 17. Initially it was 10, then you added 7 to it. So 10 plus 7 is 17. Then you did 17 mod 3. What is 17 mod 3? It is 2. So you assign 2 back to a. So value of a becomes 2. Now let's do one more operation. Let's say I do star equals to 5. That is, I'm trying to multiply 5 into 2. Last value was 2. I'm trying to multiply 5 with it. So console.log value after multiplication is, let's see. So 2 into 5 should become 10, and you can see the value is now 10. If now I want to do a minus equals to 3, console.log value after subtraction is a. Let's try to run it. See, last value was 7. So last value was 10. 10 minus 3 is 7. You're getting 7. What is left? Division. So a divide equals to 2. Right. So let's try to divide 7 by 2. So console.log value of value after division is a. Remember this, right? Mod will give you the remainder of the division. Slash will give you the quotient of the division. If you run it, oh, 1 second. Let's run it. See, 7 by 2 is what? 3.5. 7 by 2 is 3.5. Right. Now, do you have something like star star equals to 2, let's say? Let's see. Can we do something like star star equals to 2? So console.log value after exponent is, let's see. Let's put a semicolon here. See, 3.5 into 3.5 is 12.25. So it is doing exponent also. So all of these are assignment operators. All of these are assignment operators. Right. Assignment operator means you are assigning some value. So the simplest assignment operator is equals to. You assign whatever is on the RHS to LHS. But there are some complex assignment operator also, that let's say you want to first add something and then assign it back. You want to subtract something and then assign it back to the same variable. So if you want to do some operation on the variable and then assign the new value to the same variable, you can do something like this. Right? This is the use case of assignment operators. So the next type of operators that we need to discuss are called as relational operators. Relational operators. Right? Relational operators mean these are more or less done for some comparison. For example, less than, greater than. I'm not like writing explicitly the meaning, but I just can put the symbols: less than, greater than, less than equals to, greater than equals to. Right? These are sometimes also called as comparison operators. Right? So let's say if you want to do something like, is 10 less than 12, then what will happen? If 13 is greater than 5, then what will happen? Is 5 less than 2, then what will happen? So in these kind of cases, relational operators work. So let's understand the working of relational operators. So relational operators take two operands, operand 1 and operand 2. Okay, and they might be having some symbol greater than, less than, greater than, equal to, less than, equal to. Okay, what they do is they take the first value and then compare it with the second value, right? So let's say if you do 10 is less than 12, so they try to evaluate it. JavaScript tries to evaluate it. If JavaScript is able to successfully evaluate it, then it returns a true or a false. Is this statement true? Is 10 less than 12? Yes. So JavaScript will return a true. Whereas if you have something like 5 is less than 2, then JavaScript will give you false. So JavaScript will give you a true or a false statement based on the comparison. Okay. So let's talk about it with the code. So let's try to demonstrate this. One second. So let's try to demonstrate this, right? So let's say we're talking about relational operators. So we can do something like let x is equals to 10, let y is equals to 20, let z is equals to 5. We can do something like console.log is x less than z, console.log is y greater than z, and let's take one more value, console.log, and let's try to put log here as well, like x less than z, y greater than z. Now let's try to compare, is x less than or equal to z, is x less than or equal to z. Okay, then let's do console.log is x greater than or equal to a, x greater than or equal to a, right? These four operators are there. Let's see if you try to run it. So is x less than z? False. Why? Because x is 10. Is 10 less than 5? No. Is y greater than z? Y is 20, z is 5. Is 20 greater than 5? True. So you get a true. Now, is x less than or equal to z? Is 10 less than or equal to 5? False. Is 10 less than or equal to 10? Like, sorry, greater than equal to 10. Like, x is greater than equal to a. X is 10, a is 10. So, is 10 greater than or equal to 10? When you say greater than or equal to 10, then it is true, right? Because when what statement should be true? Either 10 should be greater than 10 or equal to 10. It is at least equal to 10, right? That's why we are getting a true here. So, these are the relational operators. So, this is for less than, this is for greater than, this is less than, equal to, and this is greater than, equal to. In your system, when you put greater than or equal to, in your system, when you do greater than equal to or less than equal to, you might see something like this. In my system, you are going to see something like this. This is due to difference in font. I have a different font than you. That's why my equals to is coming as a dash. Whereas most probably in your system, you will see something like this, like a greater than followed by an equals to. Right. So these are relational operators in front of you. The next type of operators that we have is logical operators. Now this is going to give you some nostalgia of your 9th class and 10th class. 9th class and 10th class. How? In 9th class and 10th class, you might have heard about Boolean logic gates. You must have heard this word logic gates. You might remember these kind of diagrams, right? Might remember these kind of diagrams like this, right? Logic gates, remember, right? So what were logic gates? What were logic gates? Logic gates were electronic circuits, or technical logic gates are electronic circuits that take some input. They take some input. Input is in the form of a boolean. Input is in the form of a boolean, true or false. In the electronic circuit, what does true means? That there is a flow of current in the wire. What does false means? There is no current flow, right? So logic gates are some electronic devices which takes multiple inputs. These inputs are always in the form of true or false. Like when you actually build the circuit, then in actual circuit it's like there, in one input there is current, in one input there is no current. But when you actually understand it, it is in the form of like true or false. When there is a current, it's a true. No current, it's a false. And based on some logic inside, it used to give some output, and that output is also going to be a boolean, true or false. Remember, right? So you might have heard about a lot of logic gates. For example, AND gate, OR gate, NOT gate, XOR gate. A lot of gates you might have heard about, right? So I can also show you some diagrams so that you guys are able to recall. So let me show you logic gates. So you might have seen images like these, right? I'm definitely sure that around in your class 10th or somewhere you must have seen these images, so you know about these, right? So now, if you know about these gates, let me first quickly talk about each gate so that we can just refresh our memory once. How AND gate works. How AND gate works. So AND gate takes two inputs, X, Y, right? And then it gives you some output, X and Y. So let's try to have those inputs. Okay, cool. So if the first input is X, second input is Y, let's see how it works. If X is true, if X is true and Y is true, right? Or let's take this example instead. Let's say if X is false and Y is false, that means there is no current in anyone. False and false is false. Okay. If one input is true, that is X is true, Y is false, then also the output is false. If X is false, Y is true, then also the output is false. If both of them are true, if both of them are true, then the answer is true, right? So if both of them are true, then the answer is true. If any one of them is a false, then the answer is false. This is AND gate, right? Let's talk about OR gate. Okay. X, Y, X or Y. Okay. If now in the OR gate, if X is false, Y is false, then X or Y is also false. But if X is, let's say, false, Y is true, then X or Y is true. If X is true, Y is false, then also the answer is true. If both of them are true, then also the answer is true. This is OR gate. Whereas we have one more gate, that is NOT gate. We have NOT gate also. NOT gate just takes one input, that is one input X, and it just gives you the output. So if you just have one input, that means X can be either true or it can be false. If the input is true, the NOT gate will give you false. If the input is false, the NOT gate will give you true. So these are the three major gates. There are more gates like NAND gate, NOR gate, XOR gate, all those. But for the timing, we need to focus on only these three because these three are our major concerns in logical operators. So first of all, we need to just make sure that we understand how these logic gates work. Basically, if you if you look at this, right, if you look at this, then it feels like when both of the inputs are false, then it gives you false. If both of the input are true, then it gives you true. If any one input is false, then also it gives you false, right? It looks like this is how it is taught in the schools also, but it's not like that. Actually, gates doesn't directly, like, there is a concept of short circuiting that we are going to talk about in a moment, right? And I'll tell you how to actually interpret these tables, but I believe everyone knows about this, right? Now, coming back to logical operators. What are logical operators? So logical operators will be having two operands, operand 1 and operand 2. Okay, operand 1 and operand 2. And in between you will be having your corresponding operator, either and operator, or operator, or not operator. Inside and or you need two operands. So let me write it here. These need two operands. Whereas not operator needs only one operand. But like, how do you write logical and? How do you write a logical and? If you have to write a logical and, let me write it here. If you have to write a logical and in JavaScript, you write double ampersand, double ampersand, without a space, double ampersand. This will represent and gate or and operator. If you have to write an or operator, then you have to put double pipe. You have to put double pipe. It's not L, it's not I, it's a pipe, double pipe. It must be above your enter button, must be somewhere around above your enter button. And if you have to put a not gate, then you have to give this tilde sign. Tilde is going to be to the left of your one button on your keyboard, right? So this is how you give operators, right? So if you have to give and gate, so this is the and operator, this is the or operator, this is the not operator. Okay, cool. Cool. Now, yeah, this is called as pipe. This is called as pipe. So you have to give double pipe. You have to give double pipe, right? So pipe is just above your enter key, right? You can Google about it. Where is the pipe in your keyboard? So let's say now, what about the operands? So the the operand that you pass are always going to be some logical Boolean operand, right? It is going to be some logical Boolean operand. Boolean, right? So let me give you an example. So let's say if you do something like console.log true and false. Now this and is an and gate. True is what? Just a true. False is a false. True and false. True and false is false. So the output will be false. Output will be false. Right? This is one way to use them. There is one more way. Console.log. You put something like 10 greater than 5 and 6 less than 3. Now just think about it. We have kind of like nested the relational operator. These are like relational operators, and then we have a logical operator also. But we know, right, relational operators always return you a Boolean, right? So what is 10 greater than 5? 10 greater than 5 is true. And what is 6 less than 3? 6 less than 3 is false. So this is technically a true and false. True and false is a false. Can I say that? Right. So let's demonstrate this example. Logical operators. Console.log true and false. or maybe console.log false or false, or maybe console.log true and true, or maybe console.log 5 less than 10 and 6 less than 3, console.log not of 3 greater than 4. Right, let's try to run them. So if you run this file, let me clear it, run this file, let's see. So the first output is false. Why? True and false is a false. Second output is also a false. Why? Because false or false is a false. Third output is a true. So see, output is true, true and true is true. Then fourth output, this is 5 is less than 10. This is true. Is 6 less than 3? False. True and false is false. This is something different. If you do 3 greater than 4, it is kind of like giving you -1. This is we are going to come back. This is we are going to come back. It's a very interesting thing behind it. Whereas if you do something like not of true, let's just try to write not of true. Now you're getting -2. You see, you're getting -2, right? So we're going to discuss about this complement, this not operator. This is going to require more in-depth understanding. But first of all, let's just go to and or, and let's first of all understand all the cases of and or. There are a lot of cases that we have to discuss. So basically, if there is directly true and false, it is going to evaluate it as true and false. If there is not directly true and false, then it is trying to see whether it is a Boolean true expression or it is a Boolean false expression. That's what it is going to try to do, right? So this is what logical operators are. We have not, this is not yet completed. We are going to discuss a few more things in logical operators, but I hope the basic understanding of logical operator is clear to everyone. So one thing to clarify, not gate is the exclamation sign. I by mistake told it is the tilde. It is the exclamation sign. Actually tilde is a different operator. We have bitwise operators also. So it is the bitwise not. So that is a separate thing. I'll talk about it today. But not gate is this exclamation sign, right? So if you want to see the not gate with exclamation sign, you can see right like this, console.log not false. If you run it, now you see not of false is true, right? So this is the logical not. Okay, this is logical not. So guys, there are two concepts. One concept is short circuiting and one concept is conversion of values to Boolean. Okay, now wherever you put a logical and or a logical or, right, you have some value to the left side, you have some value to the right side. If these values are not automatically a Boolean value, for example, if let's say you have a 10 here and a 6 here, these are not Boolean values, right? These are numbers. So JavaScript will try to convert them to a Boolean value. So JavaScript does some conversions, right? How it does the conversion? Technically, everything is mentioned in the documentation. Sometimes in the initial days, documentation can be a bit hard to read, but later, slowly and steadily, we'll discuss everything very much in detail. We can come back and you will be able to get more hang of it. But let me show you about the conversion, right? So let me open the official documentation. There you will get things about it. Uh, One second, let me open it. Okay, cool. So if you go to type conversion and to Boolean, okay, so let's see. If your value is undefined, it is going to be converted to false, right? If your value is null, then also it is going to be converted to false. If your value is Boolean, then of course it is a true or false, so no conversion required. If your value is some number, then apart from 0, -0 and nan, everything is going to be true. Only 0 minus 0 is going to be false. Strings, if argument string is of empty length, then it is false, otherwise it is true. There are two more things, symbols is true, objects are true. So technically, if you just want to summarize, let me summarize it normally. What values, let's write about what values are falsy in JavaScript. What values are considered as falsy in JavaScript? So null is a falsy value. So if you write, let's say null here, it is going to be treated as false. Undefined is a falsy value. Okay. Empty string, this is an empty string. Empty string is a falsy value. In JavaScript, you just don't have a normal 0, you have a minus 0 also. So like plus 0 and minus 0. And there is a special number nan that we are going to talk about. Nan. There is a value nan. We are going to talk about nan. So nan is also falsy. Right. False is of course falsy. False is, so of course it is a false value. And that's it. Rest everything in JavaScript, anything that you put is going to be a truthy value. Apart from these, everything is truthy. This is, you have to remember. You have to just remember these 7 values, and technically I also never remember, I just refer to the documentation. Documentation are for our reference so that we are going to become sensible programmers and not someone who just learn everything. So we can we should just know where to refer in the docs, right? So these are falsy values. Rest everything is a truthy value. Okay. Now, how JavaScript does this conversion? How JavaScript does this conversion? There is a concept called as coercion, which is also called as type interconversion. Right. And it is not just limited to JavaScript. Other languages also have their own way of doing type conversion or type interconversion. That means, let's say if you have a number, but somewhere at some place it is expected to be used as a boolean, it will try to convert it to a boolean. Right. So this concept is called as coercion. In coercion, automatically JavaScript tries to convert something. So there are a lot of rules of coercion. For example, here we wanted to convert to a boolean. So these are the rules of boolean conversion. Similar to this, we have rules of number conversion, that how number conversion happens, right? Similar to this, we have more conversion algorithms. If you see, you will be having in number conversion, you will be having to string conversion also. So there are multiple conversions that are written in the documentation that one can refer. Long story short, if you have something like this, then JavaScript will try to treat them as a boolean value only. But still, in 10 and 6 both are true, right? So why don't we get true 10? Why we only get 6? If you do console.log 10 and 6, you will get the output as 6. Why do we get 6? Why don't we get 10? So let's talk about that. Okay, let's talk about that. But first of all, I hope this concept of type interconversion is clear to everyone. So now we know that these things are falsy in JavaScript, right? These things are falsy in JavaScript. That means 10 and 6 are technically true the values. 10 and 6 are technically true the values, right? So let's actually see why the output, if you do 10 and 6, why the output comes as 6. That is something that we have to see. Okay. So I'm going to cut these tables. Yeah, I'm going to cut these tables. And let's talk about a concept called as, a lot of people call it as short circuiting, but let's see. So first, in order to understand that, we need to understand how and, or, and not actually works. When you actually see and, right, in the and table, let's first of all focus on the and table. If you see false, false, you see the output false. So you get a notion that If both of the inputs are false, then only you get a false, and that's true, right? Is the first case. When both of the inputs are false, that's a false. But technically what a AND gate actually does, right? The moment it sees that the first input is false, then definitely it doesn't matter what the second input is, right? Do you think the second input matters? In an AND gate, even if one input is false, the output is definitely false. See, one input is false, output is false. One input is false, output is false. One input is false, output is false. It doesn't matter what the next input is. For example, this case, if you, the moment algorithm says that, okay, the first input to the AND gate is false, it will directly return you a false. It never actually sees the second expression, right? It will never actually see the second expression. That's the beauty of AND gate. This concept is called as short circuiting. Like, if the first input is false, then doesn't matter what the second input is, answer will be false. But if the first input is true, then it has to see the second input, because until or unless both of them are true, it cannot be true, right? So if the first input is true, it will go to the second input, and whatever is the second input, it returns that. See, first input is true, so just return the second input. First input is true, just return the second input. If first input is false, return the first input. First input is false, return the first input. So let me write about it. In a AND gate, if the first input is false, then it doesn't evaluate the second input and immediately returns the first input, right? So if the first input is false, it doesn't matter what the second input is, it will just return the first input only. That is technically, in our case, is false. And as well as, if first input is true, then the second input has to be seen or has to be evaluated, and then second input is returned, right? So if the first input is true, then whatever is the second input, return the second input. If the first input is true, whatever is the second input, return the second input. If the first input is false, return the first input only. If the first input is false, return the first input only. That's the beauty of AND gate, right? Now, coming to the question, what will happen if you do 10 and 6? Now 10 is a truthy value. It is a truthy value. Can I say that? So whatever is the second input, you return the second input. That is why you get 6, right? Now the question that come into your mind is, let's say if you have something like 10 greater than 6 and 6 less than 7. If you do this, what will be the output of this? The output of this is going to be true. You might get a feeling, sir, why not 6 less, like 10 greater than 6 is a true? If this is a truthy value, then return the second input. So why not we get the output as 6 less than 7? Because this value can be simplified, or you can say it is an expression. It can be evaluated. Like if you just write 6 somewhere, if you just write a value 6 somewhere, it cannot be like simplified anymore, right? It's already in the most simplest form. But if you say 6 less than 7, then it can be interpreted as something like a true, right? It can be simplified to true. That is why when you see an expression like this, the output for it is true. But if you say something like 10 and 6, it just returns you 6 because that cannot be simplified any further. That means if I write something like console.log 6 and 10, what do you think should be the output? 6 is the true value, so just return the second input. Output should be 10. Let's try this. Console.log 6 and 10. If you run it, let me clear and run it. It is 10, right? This is a very, very interesting concept. It also exists in other languages, but this is actually the meaning of these gates. Now, if you talk about the OR gate, let's talk about the OR gate. Okay. If you see the OR gate, then in the OR gate, if you have anyone as true, then the output is true, right? So talking about OR gate, what OR gate says simply is, if any one of the input is true, the moment you see that any one input is true, you don't need to evaluate the second input. You see, if the first input is true, doesn't matter what the second input is, you return the first input. If the first input is true, doesn't matter what the second input is, you return the first input, right? But if the first input is false, then you return the second input, because if the first input is false, second can be true or false, right? See, if the first input is false, second can be a true, right? So you return the second one. Technically opposite going on with AND gate. So let me even write about it. In a OR gate, if the first input is true, then it doesn't evaluate the second input and immediately return the first input. Whereas if the first input is false, then it returns the second input. Right, it returns the second input. Right, for example, let's see. If you do something like console.log 10 or 0. 10 is a true value, 0 is a false value, but we have a OR. If the first value is true, you immediately return the first value. So if you see the output is 10. Console.log 6 or 19. Both of them are true, but because first value is already true, you don't even see the second value. So you just return the first value only. Right? If both of them are falsy, like 0 or 0, or let's take -0. In JavaScript, you have -0. I'll talk about the relevance of -0. But if you take, like, let's say -0, it is going to read the first input, it is false. So whatever is the second input, it returns the second input. So see, -0 gets returned. So this is the essence of OR gate. And this is the concept of short circuiting in AND and OR gate, or technically AND and OR logical operators. So before I move to the next operators, I have to talk about a very interesting thing today. So we talked about a lot of numbers, right? We know about numbers: 10, -10, 6, 5, 3.4, 8, 2. A lot of numbers are there. JavaScript actually does a very interesting thing. JavaScript gives us access to three very interesting numbers: 0, -0, and NaN. All these three are numbers. Now normal zero you know, right? Normal zero, the relevance you know, right? Everything is based on zero. You cannot do anything if there is no zero, right? What about minus zero? Why do you have a minus zero here? In languages like Python, C++, you don't have a minus zero. In JavaScript, you have a minus zero. You might think, okay, what is the use case? So I'm not sure how many of you guys have learned about the concept of displacement, velocity, these physics concepts, right? You know, right? A lot of quantities that you learn are a composition of magnitude and direction, are a composition of magnitude and direction, right? For example, if let's say you are building a game, let's say you are a game developer, right? You are a game developer and you are building a game in, let's say, in 2D plane. And let's say this object is kind of like a car or a person who is running, right? And let's say while running, they are deaccelerating. Listen to the situation. So this person is running and this person is deaccelerating. Let's say at some point of time here, the velocity becomes 0 meter per second. Okay, because they were deaccelerating. Let's say they were putting a brake kind of a thing. Okay, it became 0 millisecond. Sorry, 0 meter per second. But at the very instance, at the very instance when it like stopped there, in which direction it was actually facing, how do you know that? How do you know that? That is the interesting part, right? That is the interesting part. Because let's say you have to build a UI, you have to build a UI where you have a face of the person. So in whatever direction they were going now, you have to keep the face in the same direction. You have We have played games like Subway Surfer, Temple Run. I'm just talking about their 2D versions. So let's say your player was coming from here, and it immediately stopped here. So in which direction they were facing? How do you know that? You need to have the access to the direction, right? So there are a lot of quantities which involves magnitude and direction. And in game development, when you play like very interesting multiplayer games and everything, there are a lot of concrete physics logic that actually goes behind the scenes, right? So, and wherever physics is involved, you need to have the access of things like direction. So having negative numbers though already can give us directions, but having access to something like minus zero will also help us, because if we have a situation where the velocity became 0 millimeter per second, but we want to know the direction. So I know if it is minus 0 per second, that means it is facing in the negative x direction. So this thing can help us in directional quantities wherever we have to show directions. I hope this point is making sense to everyone. Drop a quick yes or no. What is NaN? Not a number. Not a number. Okay. NaN full form is not a number. Now, what is the use case of this? What is the use case of this? Okay. So let's say these are some buckets. Bucket 1, or let's say bucket 0, bucket 1, bucket 2, bucket 3, bucket 4, bucket 5, bucket 6. Okay, every bucket has some string, right? Some text written inside it. A, B, C, D, O, R, X, Y, Z, M, N, A. Some string is written. Yes, technically yes, written. So you have a lot of buckets, okay? And what is the question? Return the bucket number in which df string is present. You have to tell me a bucket number where df is present. So is df present somewhere? कहीं df दिख रहा है आपको? Yes, Reddy. So I want to return a number, but I want to return an invalid number, right? I want to return a invalid number because I cannot return 0, 1, 2, 3, 4, 5, 6. I cannot even return something like -1. A lot of people will start telling you to return -1. Technically, -1 is also not a good thing to return, right? Because there can be a bucket with a number -1. So if there is any situation where you are bound, so let me write it. If there is a situation where you are bound to return a number, but there is no valid possible number to return. Possible number to return. Then we use NaN. So NaN is a number that is used to show a situation of invalid number. Anywhere if you have to show invalid number, you show NaN. Let me take one more example. Right, let me take one more example. Now, let's say we can do divisions, right? I can do 10 by 3. It will return me some 3.33333. Okay. What if I do 10 by null? Let's see. Let's say if I do 10 by null. Okay. Let's see. If you run it, it says infinity. Okay. If you say undefined by null, okay, then it says NaN, right? Because you know, right, if you do something like 10 by 0, then it becomes infinity, right? It becomes technically infinity, like you write infinity or not defined. But you if have an undefined value can never be divided by anything. So no point of even getting something like infinity or anything. So you get NaN. So it's an invalid situation. It's an invalid division that you're trying to do. Right? It's an invalid division that you're trying to do. So whenever you have to show invalid situation, you put a NaN. Whenever you have to show invalid situation, you put a NaN. Right? So you can try different things and you can see in what different cases you are getting NaN. But that is the use case of NaN. But there is a very beautiful property about NaN. Very beautiful property. So it's a trivia question. Which is the only primitive value or we can say what are the let's say the question like this. Which is the only number in JavaScript which is not equal to itself? Which is the only number in JavaScript which is not equal to itself? The answer is NaN. Right? We will learn about how you can equate two numbers or something. how can you equate two numbers, or let's say how can you equate two values, like whether one value is exactly equal to the other value or not. But the only number in JavaScript which is not equal to itself is nan. This is a fact. You have to remember this. If you say why do we have it, it's how JavaScript has made it. It's like why we draw a like this. So in JavaScript, nan is the only number which is not equal to itself. A lot of people say that the reasoning is because it's an invalid number, so no point of having any kind of equality there. Right, so the only number that is not equal to itself is nan. And what is the use case of nan? Whenever we have to show any invalid number, then we use nan in JavaScript. So folks, there are two more numbers that are not very interesting, but yes, they exist. They exist in other languages with different forms also. So there is infinity. Like if you just write infinity, that is like a plus infinity, and you have a minus. If you put a minus before it, you get a minus infinity also. So let me demonstrate that. 1 second. So special numbers.js. One special number is 0. One special number is minus 0. Like 0 is like plus 0. If you write a plus 0, that's equivalent plus 0. Then you have something like nan. Then you have something like infinity. Like if you'll just print infinity, it will give you infinity, and it's a number. Okay, it's a number. It's not a string. See, no double quotes, so no string. And minus infinity. So whenever you have infinity, it's like very large value, something that you can't compute. Whenever you have to compute to some very large value, you can use this infinity with a capital I. This is a capital I, and see, no double quotes. No double quotes means it's not a string. It's a valid number. Okay. So if you run it, you see 0 minus 0 and infinity. So it will get printed like this, but you can even compare. For example, if I do, is 10 less than infinity? 10 is less than infinity, right? Plus, when normal infinity is like plus infinity. So 1 second, console.log, my bad, console.log. True. So see, you are able to compare the numbers, right? So that's the essence of infinity, and these are some special numbers that exist in JavaScript. So now let's start the discussion on the next type of operators that we have. So we talked about logical operators. So logical operator more or less acts like our Boolean logic gate, right? Now we have one more set of operators that might feel, I would say, very much related to the logical ones, but are quite different. These are bitwise operators. Bitwise operators. Now what is bitwise operator? Let's say you have a number 5. Okay, let's say you have a number 5. So internally, computer doesn't recognize this symbol of 5, right? Computer knows only binary. Computer only understands current. Computer only understands 0 or 1 internally, right? So actually internally, this 5 will be stored somewhere, somehow, somewhat like 101. Can I say that? This is the binary form of 5. This is the binary representation of 5. We can talk later about how you can do binary conversions, how do you read binaries and everything, right? We can talk about that. But for the timing, just try to understand that this 5 is in binary going to be represented like this. And I believe binary is something that is taught in schools and everybody must be aware about it as well. For example, if you, let's say, talk about something like 7, then the binary of 7 is 111. Okay. So internally, binary representations actually happen, right? Now what are bitwise operators? So bitwise operators perform the corresponding operations bit by bit on the given operand. Right. For example, so first of all, let me talk about what are the given bitwise operator. So there is a bitwise and. So remember logical and? Logical and we used to write as what? Double ampersand. But if there is a single ampersand, this is called as single ampersand is bitwise and. It is bitwise and. Single pipe is bitwise or, right? There is a cap symbol on your keyboard as well. This is bitwise XOR. You don't have a XOR with logical operations, but you have a bitwise XOR here. And this tilde is also used. This is bitwise not. Right? This is bitwise not. So now what exactly these things work? So in order to understand, I would request you to remember all the, like, keep in mind all the tables of AND gate and everything, because that is going to be still relevant. But let's say if I do 5 bitwise and 7, then what will happen? First of all, let's recall what will happen if we do 5 double ampersand 7. That is, this is the logical AND. This is the logical AND. Now logical AND will do what? Logical AND will do what? Logical AND is going to see that the first value is a truth value. So whatever is the second value, return the second value. So this will return you 7. The answer of this expression is going to be 7. This is logical AND. But what is bitwise AND? What is bitwise AND? In bitwise AND, things are going to be interesting because this bitwise AND will not work on 5 and 7. Instead, it will actually work on the binary of 5 and the binary of 7. So just write down the binary of 5, write down the binary of 7, and then bit by bit, for every bit, it will do the AND operation. So what is 1 and 1 in the AND table? What is 1 and 1? 1. What is 0 and 1? False and true is false, that means 0. Again 1 and 1 is 1. This is what? 5. So this expression will return you 5. Let's take one more example. Let's say you have something like 6 and 9. Okay, 6 and 9. So what is the binary of 6? Binary of 6 is 1 1 0. You can say 0 1 1 0. And binary of 9 is 1 0 0 1. Okay, so let's write both of them. 0 1 1 0, 1 0 0 1. Let's do the bitwise AND. Bitwise AND means bit by bit. So first of all, this bit will be evaluated. What is 0 and 1? 0 and 1 is 0. Next bit. What is 1 and 0? What is 1 and 0? 0, because 1 is true, 0 is false. 1 and 0 is false. Next bit. What is 1 and 0? 0. What is 0 and 1? 0. 0 0 0 0 is the binary of what? 0. So the answer of this expression is going to be 0. Right? That's the beauty of bitwise operators. Bitwise operators are not going to work on Boolean logics. Instead, they are going to have the bitwise representation, the bit manipulated representation of the given inputs, and then bit by bit, they are going to represent everything, and then bit by bit they are going to do the calculation, right? This is how bitwise work. If I take the example, one second, you don't need to remember all of these binary conversions from 6 to 9 or like 6 to 8 or something like this. You don't need to remember all of these. There is like dedicated algorithm that you can understand to convert these. We are going to learn these algorithms later. Don't worry on that part, right? Let's just take one more example. So let's say I take uh, 2 and let's say 5. Okay, 2 and 5. So what is the binary of 2? Binary of 2 is 0 1 0, right? What is the binary of 5? 1 0 1. If you do 0 1 0 1 0 1 and do the AND, 0 and 1 is 0, 1 and 0 is 0, 0 and 1 is 0. So the answer here also is going to be 0. Let's take one more example. Let's say 15 and 6. Okay, what is the binary of 15? 1 1 1 1. What is the binary of 6? 0 1 1 0. So let's see, 1 1 1 1 0 1 1 0. We are doing the AND. So 1 0, 1 and 0 is what? 0. 1 and 1 is what? 1. 1 and 1 is what? 1. 1 and 0 is what? 0. This is what? 6. So this expression will result you in 6. Right. Okay. Let's take one more example. Let's say we do 5 and 4. What is the binary of 5? 1 0 1. And let's say do 5 and 6. Let's do 5 and 6. What is the binary of 6? 0 1 1 0. If you do 0 1 0 1, 0 1 1 0. 1 and 0, 0. 1 and 0 or 0 and 1, 0. 1 and 1, 1. 0 and 0 is 4. What is 1 double 0? The binary of 4 is 1 double 0, so the answer is going to be 4. So this is how you do bitwise operations on any two operands, right? Now we are going to take few examples where we are going to maybe discuss about bitwise OR also. That is going to give you a bit more confidence. Other one, if you want to do the OR, for example, if I do 5 or 6, okay. So what is the binary of 5? 1 0 1. What is the binary of 6? 1 1 0. If you do 1 0 1 1 1 0, let's take 4 bits, and you want to do OR, 1 or 0 is 1, 1 or 0 is 1, 1 or 1 is 1, 0 or 0 is 0. This is triple 1. What is the decimal equivalent of triple 1? It is 7. So the answer of this expression is going to be 7. Right. Let's take one more example. Let's say you do 8 or 4. What is the binary of 8? 1 triple 0. What is the binary of 4 in 4 bits? 1 0 1 double 0. If you do 1 triple 0 0 1 double 0, you will get 0 or 0 0 0 or 0 0 0 or 1 1 0 or 1 1. This is double 1 double 0. What's the equivalent of double 1 double 0? Let me calculate. This is 2 raised power 2 plus 2 raised power 3. This is 12. So answer of this expression is going to be 12. Right. So see, I also didn't remember double 1 double 0. I just calculated. So you will be also calculating a lot of binary to decimal conversions. So this is how bitwise operators actually work, right? And similar to this, if you want to do XOR, like if you do 5 XOR 6, then this will be using the XOR table. If you do not, then it will be complementing. This is how like basic bitwise operators actually work. Now let's talk about equality operators. Now JavaScript is special because of a lot of reasons. One of the reasons are these equality operators, right? In other languages, there is actually only one equality operator. Most of the languages that at least I have worked with, like C++, Java, Dart, Python, Ruby, in all of these languages, there is only like one dedicated equality operator. JavaScript is special. Why? JavaScript has got two equality operators. Okay. One is this double equals to, and one is this triple equals to. Double equals to is called as abstract equality operator, and triple equals to is called as strict equality operator, right? Now, what is the difference between the abstract equality operator and the strict equality operator? So at a lot of places, guys, you will find the definition of these two things absolutely wrong. So a lot of places on the internet, you will find people saying that what double equals to does is it only checks the value of the operands, whereas what triple equals to does is triple equal to checks the value as well as the data type also, and double equal to only checks the value. This statement you will find at a lot of places on the internet, and this statement is 101% wrong. This is absolutely wrong. There is nothing correct about this statement. Totally wrong. Don't agree on this. I will show you proofs. I will show you references, after which you will realize that at any point of time, if you read this statement, that means that source might not be factually correct at most of the places. The most credible place to learn about things around JavaScript, where we are also going to learn that what is the difference between the two, is going to be the official documentation of JavaScript. So let me open the official documentation in front of you. So what is the myth, or what is the wrong statement? The wrong statement is double equal to checks type, triple equal to checks, sorry, wrong statement is double equal to checks values, triple equal to check value as well as type. This is wrong. Let's see what the documentation says, right? We are not someone who is like above the documentation. The final thing will be said by documentation only. Okay, so I only also already have the documentation open in front of me. So let me bring the documentation here. Okay, cool. So let me search about double equals to here, or triple equals to, or let's search about equality. Okay, see, so we have this article on abstract equality comparison, that is double equals to, and strict equality comparison, that is triple equals to. Okay, so let me zoom in a bit. Okay, abstract equality comparison and strict equality comparison. Okay, abstract equality comparison is double equals to, strict equality comparison is triple equals to. Now in this article of this official documentation from ECMA International, they make the official changes and all the official documentation around JavaScript. Read the first line of abstract equality, that is the double equals to. Read the first line. Forget about rest of the lines. Just read the first line. The first line says, if type of X is same as type of Y, that means double equals to also checks types. It might do something else with that piece of information, but double equals to also checks types. And now come to triple equal to. In the first line of the algorithm, that is the steps performed by triple equal to, the first line says, if type of X is different than type of Y, that means both of them checks the type. After checking the type, whatever the information they got, with that piece of information, they might do something else. But both double equals to as well as triple equals to checks the type. This is the most crucial piece of information that you should know. Now you might feel that how does that matter? It matters because if you will write some piece of code and you will just, without any knowledge, without any actual argument, just everywhere start putting triple equals to, it might not make sense, because if somebody will ask you, you will say triple equal to will also keep a type check, but type check can be done by double equals to also, right? Because it actually does the type check, right? So you should always know the language as well as possible, so that when you write the piece of code, you first of all know what you are writing, and second of all, you write the cleanest possible code, right? So first thing, the first myth that we are going to break here is double equal to also checks the type, triple equal to also checks the type. What is the difference? The difference is on the thing that they are going to do after getting the information about the type. Like they fetch the type, they got the type of the data, and then what they are going to do with that type, that thing is different. That we are going to talk about. Okay. So let's see the difference between double equal to and triple equal to. Right. Let's see the difference between double equal to and triple equal to. So what double equal to does is it checks the type of both operands, right? If type is same, if type is same, then it calls triple equal to. Okay. Type, the data types, for example, number, string, boolean, etc. Right. So see, if that in double equals to, if the type of x is same as type of y, then it is going to just call triple equal to only. It is going to call triple equal to only. And this is for the case when the types are same. If the types are not same, if types are not same, then type conversion, occurs, that we also called as coercion, and then comparison is done, and then comparison is done, right? Type conversion occurs and then the comparison is done. Whereas for triple equals to, it also checks types of both the values or both the operands. This time, if types are different, it returns false. It returns false. If the types are different, triple equal to will immediately return false. Whereas in double equals to, if the types are different, there will be type conversion that can occur, right? Otherwise, if types are same, then value comparison occurs. Value comparison happens. This is the actual difference between double equals to and triple equal to. That is, both of them checks type. In double equal to, if the types are different, it will try to convert the types from one type to another type. Whereas triple equal to doesn't do type conversion. This is the difference. If somebody asks you what is the difference between double equals to and triple equals to, double equals to actually do type conversion. Triple equal to will never do type conversion. This is the major difference between both of them. Let's take an example. So let's say I write 1, let's say this is the number, double equals to 1. This is a string. This is a string. Okay. 1 double equals to 1. The answer of this expression is going to be true. You might think how? This is a number. This is a string. How they are same? So let's see what double equals to does. Double equals to will check the type. Type is number here. Type is string here. So types are different. So it will try to do the type conversions. It will try to convert the type. Now, how type conversion happens? You don't need to remember. Why? Because everything is written in the documentation. You can just read the documentation and get your answer. Okay. So let's see. So if you go to line number 4, if you go to line number 4 and line number 5, both of them are like equivalent of each other. It says if the type of x is number, like one type is number and one type is string, then it will convert the string to a number. This exclamation mark is not the logical not. It is not the logical not. I'm telling you, it's not the logical not. It's for something else. It is written in the documentation only. I'm explaining you because you might feel a bit hard to read the documentation initially. So it says if one type is a number and one type is a string, it will convert the string to a number. Okay. So what it will do, what JavaScript will do, JavaScript will convert this string to a number one, and then again it will do the comparison. Now the types are same. Now the types are same. See, type of this is also a number, and because this string has been converted to a number, so this type is also a number. Now the types are same. What happens when the types are same? If type is same, we call triple equal to. So technically what will happen? We will call 1 triple equal to 1, and here the types are same. So in triple equal to, if types are same, then value comparison happens. Value is 1, hence the answer is true. And you can even check it on JavaScript. Like I can even write it in front of you. If I do console.log 1 double equals to, sorry, 1 double equals to 1. Okay. If you run it, see, we are getting true. Now just think about it. Like instead of this one, let's say I say Sanket. Now one input is a number. See, this is a number. This is a string. So you want to convert the string to a number. But how will you convert Sanket to a number? If you want to convert Sanket to a number, it will lead to an invalid number, right? And what is the representation of invalid number in JavaScript? NaN. So the answer of this is going to be false. See, false, because eventually, finally, what it will do? It will do 1 double equals to NaN. Because Sanket will get it, JavaScript will try to convert Sanket to a number. But Sanket can never become a valid number, right? So it has to give a number. So it will give an invalid number, NaN. And 1 is not equal to NaN, right? So this thing actually happens behind the scenes, right? So you can start reading this documentation. So I'll give you some basic pointers. When we will learn coercion in the dedicated lecture of coercion, then we will understand each and every line of this. In simple terms, you can understand that if x is null and y is undefined, like type, like one value is null, one value is undefined, and you double equals to, you will get a true. Same thing here. If x is undefined, y is null, you will get a true. If one thing is a number and one thing is a string, so you see, it will always try to convert the string to a number. If one thing is a boolean, right? If one thing is a boolean, doesn't matter what you have on the other side, it will convert the boolean to a number. Same thing here, right? For objects, it has to do some more things. We are not going into objects currently because, as I said, in coercion, we are going to visit it back. We are again going to come back and visit all of this theory, that how exactly step by step things work. But for the time being, for you to understand how double equal to and triple equal to works is, double equal to will do type interconversions, triple equal to won't, you see. And I told you, right, that NaN is the only value that is not equal to itself. So let's see what happens. Let's say you try to do console.log NaN triple equal to NaN. And what did I tell you? NaN is the only value in JavaScript, only number in JavaScript that is not equal to itself. If you run it, see, we are getting false. Why we are getting false? Because type of NaN is a number type of nan is a number, so it's same. So we'll come to line number 2 and see type of nan is a number. So then what will happen? If the first argument is nan, it will not even see what is the next argument. It will automatically return false. So if the first argument is nan, second argument is nan, it will not even see the second argument. It will just see the first argument and directly return nan. Sorry, directly return false. That is why nan is not never equal to itself. So you can just read this documentation at any point of time if you want to predict the output. You can just read this documentation and you will realize that what will be the output. Now you might feel how you will be doing it in interviews. Generally, this thing is not asked in interviews. And even if this is asked, you can ask for the documentation from them that please give me the documentation of abstract equality and strict equality. I will tell you the answer. This is the thing. Because as a programmer, you are not expected to rote learn everything. Rather than you are expected to understand. You have to understand the funda. What is the funda? Double equals to does type conversion, triple equal to doesn't. So you can just refer the documentation and then read about it and then predict the output. All of these, like currently I am just going through like a 100 feet view of this. When we will start the topic of coercion, then we will understand it in more depth. You know a bit of coercion already, that type interconversion is coercion, that if you want to convert a double quoted 1 or a double quoted 9 to a number, so it will become a number 9. But this is how things work. Now, if let's say you want to check the type of a particular value, how can you check the type of a particular value? So in order to check the type of a particular value, we have an operator called as typeof. You can write typeof, you can put a space, and you can put any value. For example, 1. Console.log typeof. This time I'm giving a number. Console.log typeof false. Okay. And let's say console.log typeof undefined. Okay, if you try to run it, see, type of this one is coming as what? String. Type of 1 is coming as what? Number. Type of false is coming as boolean. Type of undefined is coming as undefined. Now there is a corner case here, which is technically a historical mistake of JavaScript. Type of null. Type of null. If you do type of null, it will give you object. But technically type of null should be null, because null is a different data type. We saw that, right, in the documentation. Null is a different data type only. If you go here and check for ECMAScript data types, you can see undefined, null, boolean, string, number, and object. So they have referred null and object separately. Now you might think that if this is a mistake, like they by mistake did it, so why they just don't rectify it? Because this is going to hamper a lot of code base that has already been written in JavaScript. If they will just in one day change the type of null to start coming as null, then a lot of piece of software that is dependent on this condition, that although it is a mistake, but now they have adjusted with it for like 10-15 odd years, right? If they will just immediately change it, a lot of things will start breaking. So to provide backward compatibility, JavaScript never changes the type of value to actually null. They still keep it as an object. So this is kind of like an historical mistake that has been made inside JavaScript.